Right, guys, good morning. I think we might get started here. So it's lovely to see so many of you here this morning. I can't imagine why. I suppose, we need to talk about Kevin. I suppose before we get stuck in, it might just be worth, I'm not going to go back through the disaster that was paper one from Friday, because I think that might feel a little bit to you guys like walking back down a dark alley you were mugged in on Friday night. Revisiting the scene of the crime with your chalk outline still on the ground in front of you. But it's kind of worth just pointing out one or two little bits and pieces before we get stuck in here. That just remember, this happened back in 2023 as well. They got a really, really difficult and unusually difficult paper one, and everybody came out the same way you guys did. Panicking, freaked out, saying, I don't know if I did enough in that exam to get my target grade. All right. And yet in 2023, the same, you still 11% of people still got their H1s, other 17% got their H2s. The H1 students still got their H1s, H2s still got their H2s, and so on. And the H6s still got their H6. All right. The marking scheme will bring all that out in the wash. Okay, so the marking scheme will be adjusted to make sure that happens. Remember that the Leaving Cert exam is not a test of your mathematical ability. Thank God, I'm sure a lot of you are saying after Friday, okay? It's not a test of your mathematical ability. It's a test to see how well did you perform on this exam compared to the other 21,000 people who did the same exam you did. That's what it's a measure of relative standing. So when the papers are marked, okay, in August, remember the top 10% of that pile will end up getting H1s to make sure that the grades don't drop off a cliff. The next maybe 15, 16% will get H2s and so on. So if you're in the top 10% of performances in that paper, even if you got 63% on the exam, you will end up with a H1. The marking scheme will bring your result up over 90. That's how the marking works, okay? It's a guarantee that we get the same number, all right? That's the way you've got to start thinking about this, okay? I won't ask for a show of hands how many of you did that thing about an hour and a half into the exam where you went to the front cover and wrote down 1 to 10, and then wrote beside each question the maximum number of marks you think you could possibly have gotten there, and then added them all up and see how close to my target grade am I, and then cried for 5 minutes. All right, so I won't ask you, but an utterly pointless exercise. You could have got 64% on that exam there, but that puts you in the top 10%, you will end up with a H1. That's how the marking works. Okay, the only time I would be concerned that maybe I haven't done enough to get my target grade is if you got a very straightforward paper where you kind of feel, okay, the questions just didn't break my way. Stuff that I studied didn't come up here, but the questions are quite straightforward, so other people who study that material might have been able to answer that paper much better than I did. So they might have overtaken me in the pile. I might have slipped down the pile a bit there, and then I might not be on line for my target grade. But I don't think anybody would have looked at paper one on Friday and said, chances are there would have been people scoring really well on that paper, much better than I did, to overtake me and move higher than my paper in the pile. All right, so in that regard, I wouldn't be kind of worried about that. The reason I'm stressing this, okay, obviously, is because what we need to make sure is you're not going in tomorrow under pressure. Okay, if you kind of feel, look, on Friday I didn't do anywhere near enough to get my target grade, now suddenly you kind of feel tomorrow morning I have to do an absolutely pristine paper 2. If paper 2 doesn't go well, my target grade is out the window. And that's not the way to think. I mean, I'm sick looking at videos over the weekend of people saying, yeah, students are going to be under pressure on Monday, but that's not a bad thing, because pressure turns coal into diamonds. That bullshit, all right? Ask the billionaires in that Titan submersible how they feel about the positive effects of pressure. See what they tell you, all right? So if you're going in under that kind of pressure, you're going to find a way to screw up. And what's going to happen is you're going to come out of that exam kind of saying, I don't think I did enough on that one either, so I might as well give up, and I might as well go and see if Eddie Rockets is still hiring, okay? So you don't want to start thinking in that regard here. All you're going to do is be as prepped as you can be going in the morning, do the best paper 2 you can, and then trust that the marking scheme will do what it always does, and make sure the H1 students get their H1s, the H2 students get their H2s, and so on. That's out of your hands. All you can do is do the best paper you can tomorrow. Are we going to get an easy paper 2 tomorrow based on getting a difficult paper 1? Who knows? Okay, there's no guarantee in that. But again, I wouldn't be worried about that, because remember, your plan here is, I just want to make sure I attempt whatever kind of paper 2 we get tomorrow every bit as well as the other people who are looking for the same grade I am. If I do that, I will get my target grade, no matter what I end up scoring on the paper. That's my mentality. Just want to make sure I do as well as I can on that paper. So this is the idea that what we're going to do today is we're going to make sure, look, we've gone back to the kind of the key basics in every topic. Is he going to ask questions that kind of stay in the middle of the road now on statistics and probability? Based on Friday, I wouldn't be surprised if he asked a question on Seamus Heaney on Monday, but there's nothing we can do about that. All we can do is do the best we can with the paper that's in front of us, and if you approach it the right way, kind of say, look, I just need to keep my place in the pile. I just need to make sure that I don't answer this paper any worse than the other people looking for the same grade I am. You're going to get your target grade in August. That's all that matters. Okay, so don't worry about paper 1. Everybody found it difficult. You weren't alone. Very unusually tricky paper, the way the questions were phrased. What we'll do is, it's not going to change how we prep for paper 2 now this morning. We'll just make sure we know what all the basics are in paper. What are the things I'm supposed to be able to do going into paper 2? Go in with that toolkit, sharp and shiny, and then just see how it pans out, okay? But don't panic tomorrow if you get another tricky paper. Kind of say, look, if I do 2 poor papers, I'm in real trouble. Just try to imagine everybody's performance is down. So if everybody's going down by the same amount performance-wise, you haven't lost your place in the pile, and therefore you're still going to end up with your target grade. Okay, that's the way to think about it. Don't panic if you get a tricky paper. Okay, so as I said, the notes you picked up on your way in here, they kind of touch base with all the important stuff in Leaving Cert paper 2. Obviously, your main topics for tomorrow, it's statistics and probability, trigonometry, the coordinate geometry, the line and circle, and geometry. Okay, they're the main hitters on paper 2. And we'll kind of touch base with all of those this morning. Okay, we'll take a little break in the middle, and I will be hanging around afterwards. And if anybody wants to have a chat about something, if you kind of need somebody to settle your nerves before you go into paper 2, I'll be hanging around when we're finished anyway. I won't be kind of rushing out the door. And we'll take a little break in the middle as well, where you can, if you have any questions, you can ask me. Okay, so we'll start off looking at statistics. So the 3 statistics questions, I'm actually going to do question 2 first. I'll come back and do question 1. Do question 2 and 3 first. Okay? Now, question 2 and 3, this is the inferential stats, right? So this is what you want to make sure that you're familiar with, okay? Hypothesis testing, confidence intervals, and the normal distribution, working with Z values, okay? That's as close to a banker as we've got, right? Again, remember, there are no guarantees. You saw that yesterday, okay? That, I mean, I've been saying this all year, that, you know, we'll just, when you see a trend, pay attention to the trend, but don't trust it. Okay, I mean, induction shouldn't have been on the paper yesterday, on Friday, because it was that's 2 years in a row. That's kind of a trend, but you don't trust that. Okay, he can shake that up a little bit if he wants to. So this question, question 2, it says a social media channel claims that 65% of the population support ongoing public protests against government policy. All right, to test this claim, a random sample of 512 members of the general public were asked whether they support the protests, and 297 said that they did. Okay, so find 95% confidence interval for P, the true proportion of the population, hence carry out a hypothesis test. All right, find the range of the 95% confidence interval, and then find the sample size. You need to reduce the margin of error to 2%. So if I've read that entire question, which I should be doing before I start it, don't just kind of look at the question and get stuck in, because if you've chosen that question, how do you know part D isn't something you're not prepped for? How do you know maybe he didn't just decide part D to throw a financial maths question onto paper 2? And I'm not ready for that. So make sure you've read the entire question so there's no surprises. There's nothing hiding in the long grass. So I know what this question is all about. It's hypothesis testing and confidence intervals. So if you've been doing the class with me during the year, you know my simple system here for pulling the information out of the data. Okay? All I'm going to do there is just do a very simple sketch, and I'm going to do it where the examiner can see it. Don't do this in the margin. Make sure the examiner sees everything you write down. Okay, particularly say, for example, like question 10 on paper 1, that one where you were shifting graphs around the place. Whatever you're thinking out loud, you put down on paper, because you're not sure what the examiner can or cannot give you marks for. And in a question like that, I want all the partial credits I can get. So anything you're going to write on the page, make sure the examiner can see it. Okay, so the first thing I want to do is pick my sample size. Okay, and you can see the random sample. It's a random sample of 512. So remember, that's your value for n. So start off by identifying your value for n. So n is 512. And then pick your symbols. Remember, in inferential statistics, there's 2 types of question, working with proportions or working with means. And that just depends on what kind of question were the people in the sample group asked. If they were asked a yes-no question, then the results from your sample group will just be a list of yeses and nos, words. So you can't put those words into your calculator and find a mean. Okay, all you can work out is what percentage of the population of the sample group said yes. And remember, a proportion is just a percentage in decimal form. So if it's a yes-no question, the question would be all about proportions, right? If the question you asked your sample group produces a numerical answer, how tall are you, or how long did it take you to get here this morning, then the data from your sample group would be numbers. And I can put those numbers into my calculator and work out a mean, a standard deviation, so it'll be all about means. So the question is going to be either about means or proportions, depending on what sort of question the sample group were asked, all right? You can see in the case of this question here, he's told me it's a proportions question. So but that means my symbols are P here, and P hash down here. P for the population, P hash for the sample group. If I was working with means, it would be mu and X bar. So it should be very obvious in the question. If the word mean or proportion is not used in the question, just ask yourself, what kind of question were the sample group asked? A yes-no question, it's proportions. And one that produces a numerical answer, it's means, right? So I pick my symbols, p and p hat, and then grab the results from your sample group. So your sample group, because there's 512 of them, and 297 said yes. So p hat is 297 over 512, and always give that as a decimal, because a proportion is a percentage in decimal form. It's not wrong to leave it as a fraction, but the numbers get a bit messy. It's always much better to give that as a decimal, and that's about 0.58. So about 58% of our sample group said yes, they agree with the statement. And then the final piece of the puzzle, because there's a hypothesis test coming up, there should now be a number to go up here. There should be a number given for the population I'm going to compare my results to. If there's no hypothesis test, there won't be. Okay, that's all the information you have. But because we're doing a hypothesis test further down, there should be a number to compare it to. And you can see there's the only number we haven't used yet. That's 65%, so p is 0.65. Now, that's how I always pull the data out of an inferential statistics question. You do it like that, the question will always begin that way. And I'm going to start getting partial credits already. Why? Because I've correctly identified symbols and correctly assigned values to those symbols. Okay, so this is how you start getting your score moving, right? So now, to find a 95% confidence, remember, it's always your sample result. So it's the result from your sample group, okay, plus or minus 1.96 times the standard error. That's how you do a 95% confidence interval. And remember, the standard error formulas here are on page 34 of your formula booklet. So these guys here on page 34. And you can see on page 34, there's two different types. If I go to page 34 of my formula booklet, down the bottom of that page, you can see there's two standard errors mentioned down there. See at the bottom of page 34, they're identified here. Standard error of the mean and standard error of the proportion. So depending on which sort of question is, there proportions or mean, I can find the appropriate formula down there. So the standard of the proportion is this guy here. Square root of p times 1 minus p over n. So I just grab that from page 34. And my sample result then is going to be p hat. That's my sample result, plus or minus 1.96 times the square root. Now remember, it's written in your formula booklet as p times 1 minus p over n. And in a question like this where you actually have a value for p, it's not wrong to use p. I would always just use p hat though, because you won't always have a value for p. If you're not doing hypothesis, there won't be a value for p. You'll have to use p hat anyway. And even if you do get a value for p, I'm not sure I would trust it, because remember, that's what somebody else is claiming about the population. I want to use my own data. So it's never going to be wrong to use that as p hat instead. So again, simplify this. Don't have too many variables bouncing around in your head here. Okay, keep this simple. So that'll always be p hat. Okay, as I said, there's not only one way of doing this. If you use p here, it's not wrong. I would just stick with using p hat. Then just fill in your numbers. So it's 0.58 plus or minus 1.96 times the square root of 0.58 times 1 minus 0.58 all over n, which is 512. And now just into your calculator, and we're good to go. All right, so that's how you pull the information out of an inferential stats question, and how we would use to do a 95% confidence interval. And if I do the calculation there with a minus sign here, I get 0.54. And do it with a plus sign there, I get 0.62. And my best guess is that the true value for p is somewhere in between those two. Remember, that's all your 95% confidence interval is. It's your best guess as to what the population result would be, okay, if somebody was to go to the bother of asking everybody rather than just a sample of 512. Right? And you go back to the past exam papers and see if you can find one where there isn't some kind of a 95% confidence interval question in there. Now, I guess one of the questions, some of you guys are probably shown that it's okay to use 1 over root n instead. I would tend to stay away from that unless he actually mentions it, because there was a leaving cert marking scheme, but was it 2023 where he didn't accept 1 over root n? Essentially, 1 over root n is what this bit here is equal to if p was 0.5. So if p hat was 0.5. So if you didn't know what p hat was and you guessed whether it's right in the very middle, 50% is 0.5. If you put in 0.5, then the margin of error there ends up being 1 over root n approximately. So I would only use that if I don't know what p hat is. Okay, so other than that, because it's never going to be wrong to do it this way. Okay, you can sometimes do 1 over root n, but I wouldn't trust it. Okay, so that's your 95% confidence. So my best guess is that the actual percentage of the population that support these protests is somewhere between 54% and 62%. Okay, so then part 2, then when you're doing your hypothesis test, remember all you got to do now for a hypothesis, you got to write down your null and alternative hypotheses first. right? And remember, the quick and easy way of doing that, if you don't want to engage with the theory too quickly, all right, is whatever you've put up here in your diagram, that will always get full marks as my null hypothesis. So P, in this case, P equal to 0.65. So if I go through that kind of little method there, all right, P is equal to 0.65, okay? So I'll write down H0, my null hypothesis is that P is equal to 0.65. And that means my alternative hypothesis, HA, is that P is not equal to 0.65. Okay, so P is or is not equal to 0.65. They're my two hypotheses. Right? So if you're doing the hypothesis, what you would normally do now is you do a calculation. Calculation's already done in the first part of the question. So all you got to do now is do those three final lines. So remember, you're going to decide now whether you're going to reject or not reject H0. And how do I make that decision? I just check, is this number here inside or outside that interval? If it's inside, you don't reject H0. If it's outside, reject H0. And keep it that simple. Are there other ways I can phrase the answer, like accepting HA? Sometimes there are. But sometimes they're not correct. So if you stick with that, okay, if this value up here is inside your 95% confidence interval, fail to reject H0. If it's outside, reject H0. That will always be correct. Okay, that will never be wrong. Right? So you can see here 0.65, it's outside that range, it's bigger than that number there. So we'll mention that. So P equal to 0.65 is outside the 95% confidence interval. Okay, so say whether it's inside or outside. Remember, if it's inside, fail to reject. If it's outside, reject. Okay, so because of that then, therefore, we'll reject H0. And make sure you say reject H0. Don't just say reject, because you don't know what you're rejecting. Okay, so reject H0. And then finally, always give your conclusion. Now, this is the hard part, what the conclusion is. So just maybe spend a minute chewing your pencil on that one. Just remember what the null hypothesis H0 means. Null means nothing. So the null hypothesis is the assumption that there's no difference. That's what the null hypothesis. This is just a mathematical way of phrasing the idea that there's no difference. Okay. Now, what no difference means will vary from one question to another. Okay. So in this case, so if I reject H0, I'm rejecting the idea there's no difference. Which means my conclusion is there's a difference. So if I can now say, what does that mean in the context of this question here? That's my conclusion to get me full marks. Okay. So if you reject H0, you're concluding there is a difference. If you fail to reject H0, you're concluding that there's no difference. And then just try and interpret what that means in the context of the question. Right? So what does that mean here? We're concluding, we reject H0, we're concluding there is a difference. There's a difference between what the social media channel said and what we actually got. Therefore, what the social media channel said might not be true. So we'll say something like there's evidence the claim is false, or there's no evidence the claim is true. And it gets across the idea that that 65% might be bullshit. That's the idea. Don't say is. Don't say anything too definite. Don't say the claim is false. Say there's evidence the claim is false, or there's no evidence the claim is true. Okay, because if you say the claim is false, that sounds like you're definite, and you can't be definite when you only asked 512 people. Now, that's how we do any and all hypothesis tests, and it'd be a very, very big departure from the usual if you didn't have a hypothesis test, a confidence interval or hypothesis test, or both question on paper 2. Tomorrow, probably part of a long question. That's what the typical question has been so far. Okay, part 3 then. Find the radius of the 95% confidence, which is the margin of error. So remember, radius of the 95% confidence and margin of error mean the same thing. It's everything after plus or minus here. Okay, so that's your margin of error there, or the radius of your 95% confidence. It's everything after plus or minus. So it's 1.96 times the standard error. That's your margin of error. And margin of error and radius of the 95% confidence will mean exactly the same thing. It's how far from the middle you are, right? So I just have to work out this bit. Just that bit there on its own. Right? So if you still have it on your calculator display screen, you can just rub out the 0.58 plus or 0.5 minus in front and just work out that bit on its own. That's your margin of error. That's your radius of the 95% confidence. And that comes out about 0.043 or 0.04. Doesn't make any difference. Okay? That's just doing that little part of the calculation there. And normally I would give a margin of error as a percentage. So if you multiply that by 100, it's about 4.3%. Or if you said it's 4%, that's perfectly okay. Okay, if you round that, so it's about 4.3%. That's my margin of error. Now, that's a bit high. you probably see from most evening cert questions that ideally we want to get a margin of error of 3% or less. And the reason that's a bit high, remember, is because our sample size is a bit small. That ideally you want a sample group of around, if you get a sample group of around 1,000, your margin of error is normally down at the 3% mark, and that's normally fine. So very often, if you got a big margin of error like that, he could ask a question, how can we bring it down? Right? So if you want to get it smaller, if you want to get the margin of error smaller, obviously just increase your sample size, ask more people. Okay, in statistics, that's your go-to question. If he ever asks you, how can you do something better in statistics, ask more people. Okay, it's like, you know, in biology short questions, if you don't know what else to write down increase the surface area. Or green leafy vegetables. If you put one of those two down, you're probably going to get 3 marks, all right? So here, if you're not sure what's in statistics, ask more people. That'll invariably improve your estimate. And that's what he wants to do then in part 4, see it? Find the sample size needed to reduce the margin of error to 2%. Okay, so what does that look like? Well, remember, this is our margin of error here, 1.96 times the square root of 0.58 times 1 minus 0.58 over 512. But we're going to say, right, if we want to change that value of n, we want to change the 512 like that, what would the value of n need to be for this to give us an answer of 0.02? Remember, turn that 2% into a proportion. Okay, 0.02. So 2% as a decimal is 0.2. That's the equation you're trying to solve. Now, I got a few questions over the last couple of days from people who were kind of saying, listen, what I found myself doing a lot on paper 1 was trial and error. Particularly with that, you know, some people said, where were the sequence and series question on paper 1? Do you remember it was at the end of question 8? The altos, tenors, sopranos, basses, that bullshit question, okay? So other people said, I had one look at that and I said, I'm not doing simultaneous equations because there's 4 letters. So I just got out Captain Casio and started trying to find numbers that work. Will you give me the marks? If you got the right answer, absolutely. Right, so if you kind of said here, look, I can't solve this equation at all. So what I might just start doing is dropping in numbers here until I find whether it gives me an answer of 0.02. If you can find the right answer by doing it that way, you will get full marks. Okay, it's a bit random, so I wouldn't go down that route. So if I divide across by this first, I'll get the square root of 0.58, and 1 minus 0.5, so 0.42. You can write that if you want to, all over n is equal to 0.02 over 1.96. Just divide across by the 1.96. And now simply square both sides. Here's the square root sign. So you get 0.58 times 0.42 over n is equal to, if you just square that using your calculator, my calculator told me that's 1 over 98. So let me just put that into my calculator, 1 over 98. You can see now, just cross multiply. Okay, so multiply up like this. And on the right hand side, you get 1 times n, which is n. On the left hand side, I'm just going to get 0.58 by 0.42 by 98. And that comes out about 2339. 0.53 or thereabouts. So remember, always, always, always round that one up. Even if that was 2339.15, always round up. It just means that 2339 people is not quite enough to get you there, so it's going to be 2340. So if your sample size was 2340, that'll give you a margin of error. So as always, making the sample size bigger reduces your margin of error. Now, there's a lot in that particular question there, right? There's a reminder of how we do a 95% confidence interval, how we do a hypothesis test, and how we work with margins of error. Remember that last year, the inferential stats question was about numerical data. It was working with means. So you might get the proportions one tomorrow. Again, we're not depending on anything. I said, so don't bank on. That's the reason why I've been saying all year, when people ask me, I don't make predictions. You can see why. Nobody was ever going to predict yesterday's paper. And the key idea here is that, let's say, for example, somebody predicted that induction wasn't coming up, you left it out. That meant you couldn't do short question 6, so you had to do the other 5. So that kind of idea, when you're expecting something to come up or not come up and end up leaving out topics as a result, what that can do is limit your choice. Right, so certainly we'll have a look at both versions here, but I think it's a bit more likely he might test proportions like that in the paper tomorrow. So question 3 then does the same for means, but it just does a little bit of z values first as well. Okay, so if you look at question 3 then, the number of marks obtained by candidates in the junior cert maths exam in 2025 were roughly, there's a buzz phrase there, normally distributed. Remember, what that means is, straight away, z values. Think z values. It could be the empirical rule, but it almost certainly won't, because he examined the empirical rule last year, remember? The very first part of question 10 was an empirical rule question. He probably wouldn't ask it again. Okay, but the empirical rule is anything you do with the empirical rule, you can do better with z values anyway. So unless he mentions the empirical rule specifically, I'd be assuming it's Z values, right? So it says candidates, the mean was 166, standard deviation of 47. Candidates who obtained more than 229 marks received distinction. What percentage of candidates in 2025 received distinction? So just like I did with the hypothesis test there, I'm going to do a very simple sketch just to make sense of this in my head, because again, it'll grab partial credit. The examiner says, look, this student clearly understood what the question wanted them to do, right? So normal distribution, remember, means the graph is symmetrical. So just don't bother trying to draw a bell curve here. Okay, just an N shape like that, all right? And we say, look, the mean is in the middle. The mean is 166. That's in the very center. And then remember, where's the number 229? So 229 is up here. It's above the mean like that, 229. And we're trying to find the numbers who obtained more than 229. So I'm trying to find that bit there. That's my sketch. That's all I need. Now, any of you who've been doing this, who did statistics with me at all during the year, you know why I do that sketch. Now, remember, the key idea here is that when I look up the Z value in my formula booklet, what I need to know is, am I going to subtract from 1 or not? That's where a lot of you guys learn rules for when you subtract from 1. I'm not going to worry about rules here at all. I'm just going to check, does the number I get from my tables match that shaded area there? That shaded area is less than half. Less than half the graph is shaded, that's all that matters, right? So let's go ahead and get our Z values. Remember, the formula for getting a Z value is on page 34, but most people won't need to look that up. It's take away the mean and divide by the standard deviation, but it's on page 34 if you need it. Okay, to get a Z value, subtract the mean and divide by the standard deviation. So in this case here, it's 229. Take away the mean, which is 166. Divide by the standard deviation, which is 47. And always round this carefully to 2 decimal places, because you can only look up 2 decimal places in your formula booklet, right? So that comes out at about 1.34. Now, a few people have asked me when I'm doing this, that you see when I do the solutions here, the way it's laid out very mathematically, so P, Z less than 1.34 equals, do I have to use that phrasing? No. If your answer is correct, your examiner is going to give you full marks, right? The one thing I'd make sure is whatever way you write the solution, the examiner can follow what you're doing. So if you've made a mistake, you can assign partial. You don't have to use very formal mathematical language for every line, okay? As long as the examiner can see what you're doing, he'll give you the marks. So all I'm going to do now is look up the 1.34 in the tables. So obviously we won't do this every time, but just to remind you, page 36, 37, there's your normal distribution tables there. And to find 1.34, just find the 1.3 down the left-hand side. There's the 1.3 there. Find the second decimal, the 4 at the top there. And then if I go across from here and down that, you can see it's 0.9009, where those two meet. Again, looking up a Z value is not a difficult proposition. So it's 0.9099. So when I look that one up, I get 0.9099. Now, once you've looked up the value, then just check 2 things. Do I have to subtract from 1? And do I have to turn it into a percentage? So does he want it as a probability value, which is what that is, or as a percentage, or do I have to subtract from 1? So do I have to subtract from 1 here? Yes. Notice that that shaded area is less than half, and that number there is bigger than that, bigger than 0.5, so they don't match. What that means is the 0.9009 is what's below that line, not above it. So subtract. So 1 minus 0.9099 comes out at 0.0901. Okay, so I subtract from 1, yes, because the shaded area and the number I got from my tables don't match. And then do I have to turn to a percentage? Yes, I do. He said, what percentage you candidate? So multiply that by 100. And that's about 9.01%. So let's call it 9%. Now, the way I've written that out there, that's perfectly fine for leaving cert. So if you're wondering about how should I write, what kind of language should I use, that's perfectly fine. If I'm marking that paper, I can see exactly what you've done at every step there. I can see why you've done everything. That's perfectly fine for full marks. Okay, now that's normal distribution. And remember, that's on the paper every year as well. Okay, so this is kind of just make sure you've got your basic toolkit, that everything he normally examines, I'm able to do. And I'll just think on my feet. If we do get an unusual paper like we did on Friday, if I've got my toolkit intact, I'm in a better position to maybe think on my feet and try and tackle whatever he's asking. Question 2 here, watch out for this one, the working backwards one. Test this all the time. Okay, this is the kind of slightly trickier version. So it says, if a candidate's result was the 80th percentile, find the number of marks the candidate got. So first of all, I've got to remember what that means, what the 80th percentile means. Remember, the 80th percentile means 80% of people scored less than that person did. So your percentile is the percentage of the population who scored less well than you did. Right? So if your score was the 30th percentile, it means 30% of people got lower than you did. Okay, so it's the percentage of people got less than you did. So in this case here, whoever this candidate is, 80% of people scored less than they did. So again, simple sketch. There's my diagram like that. Okay, and there's the 166 in the middle. How many marks does this person get? Having a Scooby. Okay, so we don't know what that score is there at all. What we do know is that this here is 80%, right? 80% of people scored less than that person did. And you see, this is the way I do it. This is the way I fill out a paper. See, I'm not using very formal mathematical language. I'm using simple sketches, but I'm helping myself to the paper, and I'm showing the examiner what I'm doing at every step. This is how you write it. Don't get bogged down in very formal mathematical writing. You don't have to. As long as your answer is correct, the examiner can see what it was you were doing to get there. You're getting full marks. Okay, don't panic about the rest of it. So I have no idea what x is, but imagine that if I was to find the z score of this for this score here, for that number of marks there, I know that when I look it up in the tables, the answer I should get is, turn that into a decimal, 0.8000. That's the trick with this where you're working backwards. So when you know what percentage is below the score you're looking for, turn that number into a decimal. And then don't look for down the side table, look for inside the table. Remember, the numbers across the bottom here are the numbers that are down the sides of the tables. The numbers inside the graph here are the numbers inside the table. So remember the previous example here, see that 9%, that's that number there, that's inside the table. 9% of people scored more than that. So the numbers that are inside the table are the ones that are inside the graph, right? So inside the graph here is 80%, so we turn that decimal, we get 0.8000. So let's go and find that in the table. So I go to the tables here, I want to find a number inside the tables here that's as close to 8000 as I can get. So what's the best I can do here? Well, then we've got this one here. So here, 7995. I think that's the closest we can get. So remember, there's a z value there that's 79.95% of people are lower than. We can't find exactly 80. That's closer. In most even Cert marking schemes, he'll probably give you the marks for either one of those two. The one that's on either side, that's normally fine. I would always pick the one that's closer. Let's not give him any reason to take marks away from us, okay? Particularly in light of what happened on Friday, when I want every single mark I can get on paper 2. I'm not taking any chances, right? So what's the z value there? If I go sideways, I'll get my first decimal, so it's 0.8, and go up, I get 4. So if you're doing this question where you're told the percentage that's below a particular value, you're trying to find that value, turn the percentage into a decimal, find it inside the tables, and then work backwards to find your z value. So the z value for this number here is 0.84, right? Now all you've got to do is work backwards. So how do you find that z value? Well, you would have taken this score here, x, subtracted the mean, 166, and divided by 47, and that should give us 0.84. And now we should be in what can only be described as business. Okay, we should be able to finish it now. So if we multiply across by the denominator, multiply across by 47, like that, there you go. And you get x minus 166 is equal to 0.84 by 47 is about 39.48. And then move the 166 across, you get x is equal to, it's around about 206, I think. Okay, again, round that one up. Okay, because to make sure that if a full 80% is below that value, if you round it down, maybe a little bit less, 80% is below the value, it's not the 80th percentile. Okay, but 206 there is, I would round that to the nearest whole number because remember it's a number of marks and they're whole numbers. Okay, so that's the normal distribution there. Look at part 3. I got a few questions about this one over the last week or two. Just before we kind of do the hypothesis to finish up. So as I said, if we don't get a question on these two here on tomorrow, it'll be a big surprise. Okay, so because this is kind of the key stuff. He know you guys will have practice in the run up to paper 2. A cohort of 45 students from one school sat the junior certificate maths exam in 2025. Find the probability that the mean number of marks obtained by the students in this cohort was greater than 155. Okay, so same thing. Set the diagram up the same way. There's your normal distribution like that. Mean of 166 in the middle, like that, as always, right? Where's 155? Well, 155 is down here. It's below the mean. And then the score was greater than 155, so that's that bit there. Okay. So I know my answer has to be bigger than half, more than half. So it means 166, and bigger than 155 looks like that. Now, the only difference between this question and the very first question is this time we're not kind of saying a student is chosen. Find the probability that they scored more than 155. It's a group of people. What's the chance that their average score was more than 155? It doesn't change how you do the question in the slightest. The only difference is the Z value formula you use. So remember, when we're dealing with an individual student, as we were in the first question here. We use this formula here, the one in the middle of page 34, z equals x minus mu over sigma, just to subtract the mean by divided by the standard deviation. When we're dealing with the group, remember you've got this one on the top of page 35, this one here. Another z value, see another z equals formula there. The only difference is it has an n in it. That's the size of your sample group. That's the only difference. So we're dealing with a group here, it's exactly the same, we just use a different formula to find the z value. The way we draw our sketch is the same, the way we look it up is the same, what we do with our answers is the same. That's the only difference here. So that's your one sample z test formula there, all right? So if I just grab that formula, so z is equal to x bar minus mu divided by sigma over root n. Do you see in the case of this one here, if n was 1, if your sample group was 1 person, then this here would just be the square root of 1 and would disappear, would give you the same z value formula we had a moment ago. So the standardizing formula we used for the first question there is this one here used when n equals 1. Okay, so put the numbers in. So it's 155, take away the mean, 166, divided by the standard deviation, which is 47, over the square root of n, square root of 45. Right, there's the size of your sample group like that. Only difference. So if there's a sample group, sample size given the question, you do your z value calculation exactly the same way, just your z value formula has that root n below the line there. And now that comes out at minus 1.57. And once I've got my z value now, nothing else changes. Right? So remember, negative z value doesn't matter. Ignore the minus sign because the right and left-hand sides of the curve are mirror images of one another. And because we're not learning off rules, when we subtract when we don't need it. I just look up the number 1.57 in the tables. So if I look up the number 1.57 in the tables, okay, find the 1.5 on the side and those 7 across the top, you get 0.9418. Just looking that up as usual. And then do I have to subtract from 1? Oh. That number's bigger than half. And that shade area is bigger than half. So that's my answer. There's no need to subtract from 1 here. So I only subtract from 1 when the shaded area and the number for my tables don't match. So I don't have to change here. And do I have to turn it into a percentage? Nope. He said, find the probability. So that, sports fans, is my answer. 0.9. There's a 0.9418 chance that their average score is above 155. Now, but compared to what he can ask, Z values are, it's one of those things, I think you probably see on paper 1 that, when you get a difficult paper, I know there's not a question I'm going to struggle to get good marks on. So what I really want to try and make sure I do is I max out my score on the easier questions, the ones that I've seen before, right? So if in a horrible parallel universe where he gives you a tricky paper 2 tomorrow as well, I think it'd be very important for me to feel that, look, if we get a question on this kind of stuff here, which I can prepare in advance, I maximize the number of marks I get on that. So then I've got, at least I got some scores in the board before I start trying to take on the trickier questions later in the paper. Okay, that's how we work with Z values. So last part of this question, part B. In a random sample of 800 students who sat the junior maths exam in 2024, the mean number of marks was 163 with a standard deviation of 47. Carry out, there's a hypothesis test again buzzword here. At the 5% level of significance, the test claimed that the mean number of marks obtained by candidates had increased from 2024 to 2025. We don't care about increase there. All we care is different. So the same sequence of steps used for the first hypothesis test. Let me pull out the information first and follow the same sequence of steps. So first of all, what's my value for n, the size of my sample? There it is there, 800. So begin by pulling out your value for n. N is 800. Pick your symbols. In the first question, it was all about proportions. So our symbols were p hat and p. This time it's all about means, isn't it? Okay, because the word mean is mentioned several times here. And anyway, what's the question they were asked? How many marks did you get in the junior cert? Okay, so it's a numerical answer. So the symbols this time will be mu and x bar. So once you've put out your value for n, just pick what your symbols are then. There'll be plenty of clues in the questions which it should be. Grab the results from your sample group, and there they are. The results from our sample group is the x bar is 163. And the standard deviation sigma is 47. That's given there. Similar for standard deviation sigma. And then finally, because I'm doing a hypothesis test, there should be a number given the text I'm going to compare my answer to. Now notice, there's no number given there to compare it to. He's hoping what you'll realize is, look, you're comparing this sample group to students in 2025. And he told me earlier on in the question that the mean result in 2025 was 166. So that's the number I'm comparing it to. That might not have been obvious. That might be where you were chewing your pencil for a moment or two, okay? So we're going to compare it to 166 instead. And now, I'm done with the text. Now I can just do my sequence of steps as usual. Okay, so again, write down your null hypothesis. H0. And as always, that'll do perfectly fine as my null hypothesis. So H0 is that mu is equal to 166. And then HA is that it's not. Remember, the fact that it said increased in here does not mean we start introducing inequalities. That's not in the Leaving Cert course. It's always just equal to and not equal to. That's all we do for Leaving Cert. Okay, we're not going to deal with increased inequalities at all. Find your 95% confidence interval now, as usual. So how do we do that? It's the result from your sample group, x bar, plus or minus 1.96. Remember, that number 1.96 makes this a 95% confidence interval. That's the only one in the Leaving Cert course. Times the standard error. So we'll go and get our standard error formula from page 34. And this time you can see, because this time the question is all about means, we use the standard of the mean formula, which is sigma over root n. Okay, so there we go. Sigma over root n. And just fill in your values now. So it's 163 plus or minus 1.96 times 47 over the square root of 800. Like that. And that comes out at like 159.7 and 166.3. Now, normally there, I would be rounding that to the nearest whole number, okay, because of remarks. The only reason I took a decimal there, and the Leaving Cert examiner, I wouldn't do this, I wouldn't have thought, okay? See, if I was to round this one to the nearest whole number, it's 166. It's the same as the number I'm comparing it to. Now, he normally doesn't give them where there be any, those numbers be anywhere close. Because if the number we're comparing it to is one of the two boundaries of the confidence interval, the test is not conclusive. So normally there's a good gap between them. It'll be very, very clear whether that number there is inside or outside the interval. But if I just round to 166 here, I can't be certain. So I just took one extra decimal there, 166.3. So I know that this number here is less than that, so it's inside the interval. Now, as I don't think you'd be facing a question where you've got to make that judgment call yourself. I think he'd always put a bit of daylight between this number here and these two guys. So it'll be very, very clear whether it's inside or outside. But if it's not, just make sure you take enough decimal places to know for sure whether it's inside or outside, okay? So we'll say, look, this time mu equal to 166 is inside the 95% confidence interval. And if it's outside, you reject H0, as we did in the first question. If it's inside, you fail to reject. Stick with those two. Don't go down the route of accepting H0, anything like that, or accepting HA. Stay away from all that kind of language. Just reject or don't reject H0. So therefore, we fail to reject H0. All right? And then remember, your conclusion then. So if we reject H0, we're concluding that there is a difference. Fail to reject H0, we're concluding that there's no difference. So fundamentally, that's your conclusion. There's no difference. What does that mean here? There's no difference between the results in the junior cert in 2024 and 2025. That's what our claim suggests here. So because the claim was that the number of marks had increased, there's no evidence the claim is true. Or you could say there's evidence that the number of marks is the same, or the number of marks hasn't changed. And it gets across that idea there. You don't have to mention the claim itself. And then it gets across the idea that there's the claim that the number of marks has increased there's no base for that. There doesn't need to be any evidence for that. Now there's your inferential stats, guys, in a nutshell. All right, so the working with means, working with standard, with proportions. It'll be a major shock if we don't get one of those tomorrow, and we've done the normal distribution in there as well. So just before we bail on statistics altogether, can we just go back and just mention in passing question number 1? Because I promised you I'd have a look at it, and I'm sure you've all had more than enough of being let down by a maths examiner at this stage for one weekend. All right, so this one here, question 1. The last 2 years, sorry, not last year, the previous 2 years, 2024 and 2023, he asked as part of a short question, finding OR. So make sure you know how to use your calculator to calculate OR, the correlation coefficient. The last time he asked a proper scatter plot question like this, it was back in 2022. So again, it's possible he might wheel it out again tomorrow. Okay, we'll just cover our base here. As I said, the best you can do preparing for tomorrow is just make sure all the stuff that he examines regularly, hasn't examined for a while, I'm on top of that. So if he goes rogue again, asks something from left field, I'll just have to try and wing it on the day, think on my feet. But let me just make sure I know all the stuff that he asks normally. So we'll just blitz this very quick. There's not a lot of maths in this. It says the Corruption Perception Index, CPI, rates a country's perceived levels of public sector corruption from 0, highly corrupt, to 100, very clean. Okay, the poverty rate of a country measures the percentage of the population living on less than the equivalent of €3 per day. All right, so the CPI and poverty rate for 15 countries is shown in the table below. So you've got 15 countries there, and you're given their CPI and their poverty rate. And the first thing I have to do is to calculate OR. So again, once you've got a table of bivariate data, make sure you know how to type that down into your calculator and push a few buttons to find OR. Okay, that's something you could look up this evening if you're not sure how to do it. Make sure you can do that. As I said, 3 of the last 4 years, he's asked that calculation as part of a short question. Okay, so it ends up being minus 0.67 if you put it in there to 2 decimal places. It's minus 0.67. Now, as I check that, if you're not sure to do that, make sure you can. Practice that and make sure you can do it. So in terms of using your calculator, for statistics tomorrow, you need to be able to find OR using your calculator for bivariate data. And then for either a list or a table of data, I can find the mean and standard deviation. They're the calculator things you need to be able to do for tomorrow. Right. So part 2 then. It says the less corrupt a country is perceived to be, the lower the poverty rate. Based on the given data, comment on that. Right? Comment on that statement. Does that look right? Right. So there's 2 things that I'd be commenting on. All right. That first of all, what does that value there tell you? Well, remember what that value there tells you, what the value of OR tells you. First of all, because OR is negative, it means there's a negative correlation, which means as one of these things goes up, the other goes down. Right. So in other words, as CPI goes up, poverty rate goes down. I guess the question that some of you might be wondering there is, hang on, if I put this in my calculator, which are the X values, which are the Y values, right? So in a table that's done normally, where it's hard, the top line will be your X values, and the bottom line will be your Y values. In a vertical column like this, the left hand will be your X, the right hand will be your Y. Okay, that's the way the data will be presented. So in this case, CPI our values are X values, and poverty rate values are Y values, right? So in this case, because it's negative there, that means as CPI corruption goes up, poverty rate goes down. That's what a negative correlation would mean. And remember, how strong is it? So that's what this also tells you here. Just remember, if your value for OR is 1, that means the correlation's perfect. It's a perfectly straight line on your graph, right? So 1 is perfect. If your value is between 0.7 and 1, that's a strong correlation. Means there's a good solid relationship there. Between 0.4 and 0.7, that's moderate. It's kind of middling. There's a few exceptions there. There are outliers. And between 0 and 0.4, that's weak. There's no real pattern there at all. Okay, so remember that's very reliable for the data sets that you guys will be dealing with. So look at that number there, minus 0.67. That's down in the moderate range. So in my head, that means there's a moderate negative correlation. Moderate because the number is between 0.4 and 0.7, and negative because the number is negative. Okay, so there's a moderate negative correlation there. And look at the graph on the next page. The reason why it's see it there, that the reason why it's moderate is to see the way there's a few points here that are kind of pulled away from the pattern a little bit. They may be not all outliers, but because they're not very well bunched together, that's why it's down the moderate range. Okay, we don't have to worry about that, but that's the reason why it's the moderate range, because the graph's on the next page. So there's a moderate negative correlation, and then what does that mean? Remember, just say what moderate means, or sorry, what negative means. It means as this goes up, that goes down, right? So what that would mean there is, in this case, as corruption goes up, poverty rate goes down. And that's kind of what they're saying in the statement, isn't it? They're saying here that the less corrupt a country is perceived to be, as corruption goes down, and as CPI value goes up, remember, I should say, because the higher it is, the less corrupt the country is. So as your CPI goes up, your PR goes down. Okay, that's what the graph seems to suggest here. The only thing I would comment on here is that, see the way he's saying it like it's an absolute rule. See the way he's saying it like it's a definite rule. The less corrupt a country is perceived to be, the lower the poverty rate. Okay, there's nothing in there to soften the language. So I would say what's better there is the less corrupt a country is. Okay, you don't have to write the whole thing out there. The lower the poverty rate tends to be. That's what I think that a lot of that question would get at. That broadly speaking, yes, the pattern is what he's describing there. as a country is perceived to be less corrupt, the poverty rate goes down. So remember, as your CPI goes up, it means you're less corrupt. Your poverty rate seems to go down. But it's not an absolute rule. It tends to be. Okay, the same reason in the hypothesis we say there's evidence the claim is true. We don't say the claim is true. So in statistics, when you're basing it on samples, okay, never say anything definite. And never allow somebody to make a conclusion that sounds definite. You can't be definite based on a sample group. So if I was just phrasing it that way, that answers the question for the example. That's the comment there. Just anything that gets across the idea, it's too definite. The pattern seems to be what he's describing here, but the statement is too definite. It sounds like it's a rule, and it isn't. So then you've got your scatter plot. And the last part of the question is to find the equation of the line of best fit. Now remember, he could have asked you to draw the line of best fit yourself. He didn't here, he did it for you. Remember, if I'm doing a line of best fit, I would normally find that point x bar, y bar. X bar, remember, is the average of the x coordinates. So it's the average of the 15 CPI values there. Y bar is the average of the y values, the average poverty rate, because your line of best fit will always go through that point, right? So if you found the point x bar, y bar, marked on your graph, and just draw any downhill line going through it, you're going to get full marks for your line of best fit. Okay, so it always goes through the point x bar, y bar. You don't have to use x bar, y bar, but you can kind of guarantee yourself full marks by using that. But in this case, it's done for you. So by taking readings from the graph, you're asked to find the equation. So obviously, you might all have slightly different values here, get slightly different answers. All you need is 2 points. Do this using coordinate geometry. Yeah? So what I'd be saying there, remember, to get the slope, I'm not going to do the entire calculation out. I've done remember, the solutions for all these questions are at the back of the handout. Okay, if you want to try them, you have a look over them yourself. But the slope is y2 minus y1 over x2 minus x1. Remember, just coordinate geometry there. So you need 2 points. And because he said by taking readings in the graph, show him that you did that. So say, for example, if you pick any number here, let's say, for example, I pick the number 20. See it? And go up from 20 till I hit the line and go sideways. That looks like the point 20, 2.5. See it? So there's 1 point on my graph. And then pick another one. You can pick another one right beside it. You can go to, I'm kind of trying to see if I can find places where the line tends to go through corners. That looks like a nice one there as well. Look at that one. So 80 and 1. Right? And then I'll just use those 2 points there to find the slope into y2 minus y1, so on. Yeah, I'll go from there. But I put those lines in the graph to show the examiner where those 2 points came from. And remember, particularly if you drew the line of best fit yourself, literally everybody in the room could have a different line of best fit, a different slope, a different equation, and everybody gets full marks. As long as your calculation is correct based on the line you drew, you get all 10 marks of this bit. So don't worry if yours doesn't match the marking scheme. It doesn't have to. As long as it's right from your line, you get full marks. And once you've got the slope, then remember, you can use the equation formula, which is also, remember, that's on page 18 of your formula booklet. And so is this one. Y minus y1 equals m times x minus x1. So just use those two there to get the coordinates. So that's really all you have to be familiar with for scatter plots. How to find or, how to comment on the pattern using your value for or, how to maybe draw a line of best fit, but certainly how to find its equation, slope, and its formula. Right, guys, that's so much of the stats we're going to do. Okay, so that's a good chunk of the paper done there with statistics, right? So certainly the inferential stuff, normal distribution, and maybe scatter plots. Just make sure we've got that ticking over. He has in the last couple of years asked, the measure, location, spread. He asked that a little bit maybe as part of a short question. You could glance over that if you're not okay with that, but that's the big stuff I'd make sure I have in my toolbox for statistics. So we'll do next, we'll have a quick look at the probability, then we take a little break after probability. I think after statistics and probability, you definitely need a break. So we'll do stats and probability first, and we'll take a little breather then, and then we'll just do the geometries and trig in the second part of the class to bring us up towards the end. Okay, now probability. So we'll start with question 4. Now he asked a real stinker on this last year, you'll remember. Okay, that question 9, part C and D was really horrible last year. All right. So the first thing to be clear on when you're dealing with statistics is permutations combinations. You can see how commonly they're becoming now. Part of a short question or tag on the end of a long question. He's very fond of permutations and combinations now, having kind of left it alone for quite a while. Just remember when you're dealing with this type of maths here, when you're dealing with permutations and combinations, it's all about, if I put a set of objects on the desk in front of you and say, come and pick any set you like, does the order you choose them in matter or not? Okay, so it's all about choosing objects from a set and whether or not the order matters, right? So if the order matters, The order you choose things in matters. That's a permutations question. Okay? So if order matters, that's a permutation question. And remember, another word for a permutation is an arrangement. And again, the reason why I'm stressing, I remember on Thursday we were talking about kind of the buzzwords to watch out for the verb arrange. So if you're arranging things, it means order matters. Okay? If order doesn't matter, so if the order you choose things in doesn't matter, that's a combinations question. And another word for a combination is a selection. So again, keep your baby blues peeled for the word select. Okay, so you select things. So remember, so a good example, like combinations are like teams and committees. Because it doesn't matter what order you choose the players for a team, all that matters is the set of players you end up picking. A manager selects a team, okay, because order doesn't matter. Okay, codes in particular are examples of permutations. Where, you know, if you got a pin for your ATM card, all right, it's 4 digits and the order you put them into the machine matters. So order matters there. So permutations and combinations. So in this case here, it says using the letters of the country France, how many different rearrangements? Okay, so the order matters here. Of all 6 letters are possible. Now, there's a few ways of doing this. You could do this using the NP/or button on your calculator. You could do it using factorials, although he did test factorials, remember, in question 6 on Friday, so he might not go near that again, all right? But you don't have to use those. I tend to use the hangman method, right? So, because remember, because I'm picking rearranging 6 letters here, I've got 6 slots to fill. The letter that goes first, second, third, fourth, fifth, and sixth. And because there's completely free choice here, any of the 6 letters can go first, then any of the 5 that are left can go second, then 4, then 3, then 2, then 1. And I just multiply all those together, and that's my answer. That's 720. Or you could put it as 6 factorial or 6p6, whichever way you learn to do it. They're all the same. They're all correct. They're all full marks. Right? That's easy enough to get started. Now, the reason I like the hangman method like that, remember, because if there's a restriction imposed, you can deal with the slot the restriction applies to first, okay, and then worry about the others. So in this case here, how many rearrangements of any 5? So we're not rearranging all 6 here. So imagine I've got those 6 blocks, F, or A, N, C, and E on the desk in front of me. I say, look, take any 5 of those and I can put them in any order you like, right? So this time, because I'm only picking 5 letters, I've only got 5 slots to fill, right, like that. And the restriction is that the first and last one have to be vowels. So that has to be a vowel, and so does that. They have to be vowels. Let's fill those 2 slots first. So because there's only 2 vowels, A and E, all right, one of those 2 vowels has to go here. And then whichever vowel I haven't used yet has to go there. So I'll fill those 2 slots first, the ones that have to be vowels. Right? That's restriction dealt with. So now remember, I've got 4 blocks left on the desk in front of me. The F, or N, and C. Any of those 4 can go here, then 3, and then 2. That's what that one looks like. So deal with the slots the restrictions apply to first, and then fill the blocks like that. And that comes out at 48, and that's your answer. Okay? So it's a permutations question because order matters here, and the hangman method is a nice way around it. Now, look at part 3. How many different rearrangements of all 6 letters are possible that contain the word can? That is letters C-A-N side by side in that order. Now, the trick here, remember, when things have to remain side by side, is to imagine gluing them together. So suppose you take those 3 blocks, C, A, and N, and you glue them together side by side like that. So they're now a single object. Then you've got the F, the or, and the E separate like that. So now really there's only 4 blocks. Treat the things that have to remain side by side as a single block. So if the C and A and N have to remain side by side, let's glue them together, treat them like 1 block. So there's only 4 blocks. The F, the or, the E, and then can, right? And then we just shuffle those 4 blocks. Right, so we've only got 4 slots to fill here. There's no restriction. So 4 by 3 by 2 by 1. Okay? And that comes out at 24. And in the case of this question, that's your answer. Right? Remember, I don't have to look at how many different orders those 3 could be glued together, and because we're told it's C, A, and N side by side in that order. If I glue those 3 blocks together in a different order, I don't have the word can anymore. Okay, so that's it. My entire answer there is 24. Right? If the question said the letters C, A, and N side by side in any order, I would have to, as we'll see in a second, look at the number of different orders I could arrange those blocks and then multiply the two of them together. I'll show you one of those now. But I don't have to do it here because CA and N have to be side by side in that order. Right? Look at part 4. How many different rearrangements of all six letters are possible in which the 4 consonants are all side by side? Now that means all 4 consonants have to be together. They don't have to be in any particular order. So again, imagine if they have to be side by side, imagine gluing them together, right? So you take your 4 consonants. Okay, and notice I'm not going to draw your attention to the difference between a vowel and a consonant. If you don't know what that is, add that to your list of things to look up this evening. What's a vowel? Okay, we'll maybe just check that. Okay, so F or N, and he won't tell you that in exam. The examiner's not going to explain what a vowel is. He'll kind of say, look, if you don't know what a vowel is, your problems run much deeper than not being able to answer a Leaving Cert maths exam. Okay, you're the keeper with the tranquilizer gun sitting beside you. Probably should have been keeping a little more close of an eye on you. All right, but in this case, we've got the 4 consonants, then we've got these 2 here, the 2 vowels. So now there's only 3 blocks. All the consonants are a single block, and I've got the 2 separate vowels. So I'm only arranging 3 blocks. See it? So 3 by 2 by 1, which is 6. But this time, because those 4 consonants can be side by side in any order, we've got to look at the number of different ways we could have glued those together in the first place. We didn't have to do it in the previous question because we were told CA and N had to be side by side in that order. So that's the only order I could have glued the 3 blocks together in. But this I can glue those 4 consonants together in any order I like. So how many different orders could I do there? Well, again, it's just 4, 3, 2, 1. 4, 3, 2, 1. Multiply those together like that. And that's 24. And then we just multiply the 2 together. 24 by 6 is 144. So when things have to remain side by side, treat the objects that have to remain side by side as a single block, and then rearrange the blocks. And then ask yourself, how many ways could you have made that block in the first place? And multiply the 2 answers together. Now think about the last one there for a second. If a random rearrangement of all 6 letters is generated by a computer, find the probability that the 2 vowels are not side by side. That's a nice question because there's a few bits to that one there. Okay, so people are I've practiced my permutations, but I haven't seen one like that before. What am I going to do with this? Okay, so first of all, the 2 vowels are not side by side. So find the probability that the 2 vowels are not side by side. So it's the same as the previous question. If you want to find the probability that the 2 vowels are not side by side, find the number of permutations where they are and subtract that from the total. That makes sense? That's the way we do that when they're not side by side. Don't start trying to deal with combinations where, look, the first and the second, the first and the third one are vowels, or the first and the fourth one are vowels, or the fifth and the third one are vowels. Don't go down that route at all. Just say, look, find the number of arrangements where they are side by side and take that from the total. So now, how many arrangements are they side by side? So imagine gluing the 2 vowels together, like that. And you've got your 4 consonants, F, or N, and C, like that. So now we've got 5 blocks. The 4 consonants and our block of 2 vowels, and we just want to rearrange those first. So 5, 4, 3, 2, 1. No surprise there, which is what, 120. So that's the number of different ways we can arrange it. And then again, because the 2 vowels could be in either order, how many different orders can I put those 2 blocks in there? So again, that's just 2 by 1, which is 2. And then multiply the 2 of those together. 120 by 2 is 240. So there are 240 different arrangements where the 2 vowels are side by side. Right? How many arrangements are there all together? Go back to part 1. See it, part 1. Then when it's possible altogether, 720. So there's 720 rearrangements possible altogether. 240 of those have the 2 vowels side by side, so all the rest of them don't. Okay? So 720 minus 240 is 480. So it's 480 of different arrangements where the 2 vowels are not side by side. And then to give that as a probability, remember it's just 480 over the total 720, which simplifies to 2/3. Okay, now, just the last part then, part B. And there's a part 2 here, which is maybe slightly alarming. Again, just let's say we get some tricky questions on paper 2 tomorrow. I honestly am, in all fairness, I don't know that tomorrow could be as difficult as paper 1 was, because paper 1 is the more abstract paper. It's algebra and graphs and stuff. It's much easier to ask questions there that are harder to visualize. Less so on paper 2, the real world application of paper 2, that there isn't really much you can do there to make that hard to visualize. So there's kind of less scope for him to go rogue and go off the reservation in paper 2 than there is in paper 1. So it's probably going to be a bit more straightforward. But I mean, it doesn't make any difference. You can't prep for questions that you haven't seen before. All you can do is make sure the stuff I should be able to do, I can do, and then just see how the chips fall. Okay? So look at this one, part B1 there. Units of the country, Greece. How many different rearrangements of all 6 letters are possible? And then part 2. How many arrangements of any 4 letters are possible that contain only 1 letter E? That's the part of the question that people find difficult. So let's look at part 1 first of all. Think about that for a second. There's the word Greece. Because I've done this already. Because it's 6 letters again, right? So it's 1, 2, 3, 4, 5, 6 slots to fill. 6, 5, 4, 3, 2, 1. So it's the same as part 1 of the question. It's just 720. It's not. There's an extra step here. Do you see the extra step? What the different? And he hasn't asked this yet. See what makes this one different? In the first country we had up here in France, all 6 letters are different. In this one down here, do you see the way the letter E is repeated? So remember, if I start moving the E's around, the sequence of letters remains the same. Okay, just I've got E's in different positions here. So because there's a repeated letter here, I've got to account for that. And all you've got to do is work out how many different orders could the 3 E's appear in, and divide your total by that. So because there's 3 E's here, it's just 3 by 2 by 1, which is 6. So divide 720 by 6. If there was 1 repeated letter, so if there was a letter that's repeated twice, I divide my answers by 2 by 1, which is 2. Let's say there was a country where there were two letters that were repeated twice. So it's like there was a pair of T's, there was a pair of S's or something. Okay, you divide by 2 for the 2 T's, and then divide by 2 again for the 2 S's. Yeah, so just divide by the number of ways any repeated letters could themselves be reordered. Okay, so the answer there is 120. Now, I'll come back and do part 2 in a second when we've done the next question, because the next part of the question here, that brings in combinations. I want to show you that. So I'll come back to that one now in a second. I think I've established my track record now. I told you I was going to come back to question 1, and I did. So I'm not going to tell you to come back to that, then not come back to it. Okay, I'm hoping that I've earned your trust in that regard so far. So we'll just do question 5 very quickly. Now look at this thing here. Okay. So it says a card trading game is played with a deck of 9 cards. Each card depicts an alien creature, as shown in the diagram opposite. Each creature is given a strength rating between 1 and 3 stars. There's 4 1-star creatures, there's 3 2-star creatures, and there's 2 3-star creatures. Okay, so 2 of those 3 stars. Now, straight away, that for me, this one here, he doesn't look like a 3-star creature to me. That looks like a beta, if ever I've seen one. All right? So there's obviously something going on there we're not seeing, but that doesn't look right. Anyway, we're not going to assess the strength. We don't know how this was decided. Let's not go down that dark alley. But that certainly, if I was going to pick one of these to beat the shit out of, that guy there in the middle is the first one I'm going for. And I clearly would have got it wrong. There's something going on. He's a 3-star creature. All right? But 4 of them are 1-star, 3 of them are 2 stars, and 2 are 3 stars. At the start of the game, a player is dealt a set of 3 cards at random from the shuffle deck of 9 cards. Part 1, how many different combinations? See it? So you use the word combinations there. Or if he told you you were selecting 3 cards from a deck, he's telling you the order doesn't matter. If you're playing a card game, when somebody deals you cards, it doesn't matter what order the cards are dealt to you in. All that matters is which set of cards do I end up with. Okay, that's why this is a combinations question. And we're there doing with the NCR button of your calculator. So that's an easy one there. So there's 9 cards altogether, and you want to pick any 3. N9C3. So combinations are done with the NCR button of your calculator, and that's easy if that's 84. So there's 84 different 3-card combinations you could be dealt with here, right? Now look at part 2. How many different 3-card combinations are possible that consist of creatures that all have different strength ratings? So all 3 cards have different strength ratings. So all you're going to do with one of these, okay, with the combination, is pull the large deck of 9 cards apart into smaller groups and see how many do I pick from each of those groups to give me the outcome I'm looking for. So instead of thinking of it as a single deck of 9 cards, right, think of it like this. It's a deck of 4 1 stars, 3 2 stars, and 2 3-star creatures. Okay, so you've got 4 creatures that are 1 star, 3 that are 2 star, and 2 that are 3 star. Okay, so just put it apart like that. And how many do I got to pick from each of those to give me the requirement? I want 1 from each. I want to pick 1 of the 4 1-star creatures, 1 of the 3 2-star creatures, and 1 of the 2 3-star creatures. So if you just do that, it's 4C1, 3C1, 2C1, and that comes out at 24. Okay, so when you're dealing with a restriction there, just divide the larger group into smaller groups, see how many I've got to pick from each of those groups to give me the outcome I'm looking for. Now, look at part 3. This is a little bit like the one he asked last year. Okay. In how many different ways can the full deck of 9 cards be divided into 3 sets of 3? Okay. So again, probability is one of those questions, I suppose, tomorrow, guys, that if he's going to ask you something a little bit unusual, a little bit hard to get your head around, probability is where it'll happen. Happened last year where he asked a question along these lines. That's where you catch you at. Probability is the one that very few people have really good feel for. All right. So the key thing with a question like this is, can I say, look, I'm not sure I'm going to get full marks on this, but I don't want to get 0. Remember, as I said, I'm hoping the message you got from what I said at the start of the class here is, all I'm going to do is keep my place in the pile. So as long as I'm not answering this paper worse than the other people who are looking for the same grade I am, I'm not going to lose my place in the pack, and I'm not going to lose my target grade. What I want to try to avoid is that the people who are looking for the same grade I am are doing something I'm not and overtaking me and pushing me further down the pile. If I could just keep in the same on the same level as people who are looking for the same grade I am, I'll get my target grade. So in a case like this, I don't feel I have to get full marks here, but I don't want to be part of the grade unwashed who gets 0 and leave it blank completely. So can I pull something out of this here? Okay, so I'm dividing the group of 9 cards into 3 sets of 3. How would I do that? Well, even if I just did this much, let's see how we can pick the first 3, right? So I say, look, there's 9 cards in the deck. I'll pick 3 of them. Correct. That's how you would choose your first set of 3, right? Now, once you've done that, there are 6 cards left, aren't there? And I want to pick 3 of those to be my second group. So now we'll go with 6C3 like that. And then there's 3 cards left. I want to pick all 3 of those. There we go. So pick 3 of the 9 cards to make to be your first hand. Then pick 3 of the remaining 6 cards to be your second hand. And then pick all 3 of the remaining 3 cards to be your third hand. And that comes out at 1680. Now, if you do that, that's a big chunk of the marks. That's the high partial. It's not the fully correct answer yet. There's something I haven't considered. But if I get that far, I'm not getting 0. That's the problem with a lot of people said with last year's question. I would never have seen how to do that. No, maybe not. You wouldn't have seen all the moving pieces. But if I've seen that much, there's the high partial. That's how I keep my place keep or improve my place in the pile, and that's how I get my target grade. Remember, it's not you against the paper, it's you against the other 21,000 people who are doing the same paper you are. Try and just say, the more of those you can stay ahead of, the higher the grade you'll end up with is. That's your mentality, okay? But the reason that's not the right answer is, let's say, for example, if you, let's say, the first 3 cards you picked were A, B, C, right? If they were labeled A, B, C. Then the second set of hand was D, E, F, and the third hand was G, H, I, right? So that's one of those 1,680 ways there. Suppose I shuffle the deck and start dealing them again. And this time, the first hand I deal is G, H, I. Okay, then the second hand I deal is A, B, C. And the third hand I deal is D, E, F. Do you see the way? Isn't that the same 3 combinations? They were just dealt out in different orders. So for that reason, I have to work out how many different orders could those pairings occur in and divide accordingly. So because there's 3 different pairings possible there, all right? So the number of orders there, just for any set of pairs, so say for those 3 pairs there, how many different orders could they appear in? 3 by 2 by 1, which is 6. So I want to divide 1680 by 6. Okay? 680. And that's what? That's 560? No, it's not. I think that answer's wrong. It's smaller. I think I made this typo there. I think it's a solution, but 160 divided by 6. 280, sorry. Thank you. Thank you. 280. Okay, so it's 280. That's the right answer. All right, so you said, look, I would never in a million years have thought of that. Okay, so you're only going to get 3 out of 5, or you're only going to get 7 out of 10. That's a lot better than leaving the whole thing blank. So if you get a really awkward one like that, don't be afraid to try parts of it, okay, and try it a second time. Remember, if you try the same question a second time, the examiner will mark both attempts. Whichever one earns the highest number of marks, that's what you score. Okay, don't be afraid to try it a second time. And the last one, part 4, if a player is dealt out 3 cards at random, find the probability that the set contains at least one of the creatures with a 3-star strength rating. At least one of the creatures with a 3-star strength rating. So think about that for a second. How would I have done that one? The player's dealt a set of 3 cards at random. Find the probability that the set contains at least one of the 3 stars. Well, what you could do there, couldn't you, is find the number of hands which contain both and find the number of hands that contain one and add them together, right? So you could have done that. So look, there's 2 cards that have a 3-star rating, and there's 7 that don't. So I could say, look, let me just pick one of those and 2 of those, right? So that's the number of hands where you get one of the 3-star creatures, right? And then you've got the same again here, 2 and 7 of that, or you could pick 2 of those and 1 of those. So both of those answers there will give you that. So this one here turns out to be 42, and that one there turns out to be 7. So if you add those together, that's 49. There are 49 hands altogether where you get at least one of the 3-star. That's the hands where you get one of them, and the hand where you get both of them. A hand where you get both of them, right? So I'll add those together, that's a total of 49. Couldn't you also have said, if it was a bit more complicated, let me find the number of hands where you don't get any of them and subtract from the total? Yeah? So I could have done this instead, couldn't I? Said, look, there's the 2 3-star creatures, there's the 7 that are not. If I get none of those and 3 of those, okay, like that, that's 35. And then subtract that from the total, which is 84. 84 minus 35 is also 49. So you've got those 2 options there. Okay, work out the number of hands where somebody gets at least one of the 2 3-star creatures. That's either work out whether they get one of them or whether they get both of them, or else find the number of hands where they get none of them and subtract it from the total. Up to you. And then put that over the total. So the total is going to be 49 over 84, because it's a probability question. Put the 49 over 84, and that comes out at 7 over 12. And that's your answer. So there's there's combinations and permutations, okay? As I said, becoming more popular now, either as part of a short question, full short question, or tagged on the end of a long question. If he's not sure what to do to flesh out a question, he tends to tag on a permutations or combinations question. Look at the last kind of 3 or 4 years, how often the E part of a long question is just something random on permutations or combinations, right? So just to clarify, if we go back to that, then that last part of the previous question there, just to show you that, part 2 on the previous page. Because we're near there, I said once we get the end of the probability now in a second, because we haven't got much left to do, we'll take a little breather, take a short break. Okay? So part 2 then, how many arrangements of so again, we've got that as the word Greece, and we're trying to rearrange any 4 of them that contain only one letter E. That'll catch a lot of people out, because they'll go straight to this, won't they? They'll say, look, we're trying to rearrange any 4 letters, so that means 4 slots to fill. Yeah? But then how do I make sure that only one of them is an E? Right? So now I'm sitting there hitting my face off the table. Right? Because I'm not sure how, I know that they're kind of rearranging any 4 letters, but I'm not sure I make sure that only one of them is an E. Okay, that's a problem. Because do I consider the possibility where the first one's an E, and then how would I fill the other slots there? And that's not wrong. You say, look, let me work out the number of arrangements there where the first one's an E, and the other 3 are not. Okay, and then work out where the second one's an E and the other ones are not. If you get a solution that way, perfectly fine. But here's the way I would think of that. How about we pick our 4 letters first, make sure there's an E in there, and then see how many different orders we can put them in. Right? So imagine that you've got the entire set of letters of the word France there. Somewhere you've got 3 E's. Sorry, Greece we're dealing with. So there's 3 E's, and there's 3 letters that are not E. Right? So the letters of the word Greece there's 3 E's, and there's 3 letters that are not E's. So let's just choose a set of 4 letters that contain one E, and then see how many different orders we can put those letters in. That's how I would think about this one. Now, as I wouldn't be wrong if you kind of said, no, I wouldn't have done that at all. I think what I would have done is I would have said this. Let's say, how many arrangements were the first one's an E, right? So if the first letter here is an E, you can see I've got 3 choices there because it's 3 E's. I have the 3 E's to go first, yeah? And then now the 3 letters that are not E's, they have to start going 3, 2, and 1 to finish out the combination. I could do that. That's perfectly fine, okay? But I'm going to do it this way instead. I say, let me pick here. So I want 1 of the E's and 3 of the not E's. Okay, if you want to visualize it like that, okay? So I'll pick my 4 letters to begin with, and that comes out there at 3, right? And then, okay, so it's 3 different combinations there. See how many different orders you can put them in. So now you've chosen your 4 blocks. You come up and say, look, there are 6 blocks on the table here, G, or, C, and 3 E's. I came up and chose a set of 4 letters, the G, or, and C, and 1 of the E's to go with it. Right, so now I've chosen my 4 letters. Let's see how many different orders we can put them in. So I've now got 4 blocks in front of me. Let's just fill the 4 slots now. There's no further arrangements. So 4, 3, 2, 1, like that. Okay, and that comes out at 24. And then we multiply the 2 of them together, and we get 72. 72 different arrangements there of 4 letters here that contain only 1 of the letters E. Now that's a tricky question, but again, don't be afraid of questions like that tomorrow, guys. As I said, just the key thing is, remember, everybody will find them as hard as you do. So I just want to keep my place in the pack by making sure nobody else is doing something I'm not. I'm going to try something. Okay, now question 6. 6 and 7, the last 2 here, because that's more than half the questions done in less than half the time. So we can take a little bit of a breather then, give you a chance to stretch your legs. Okay? So question 6 here, this is expected value and Bernoulli trials. Now, if he doesn't ask Bernoulli trials, again, take that personally. Okay, I mean, you know, on the back of the paper one you got on Friday, if he then starts doing a paper where he doesn't test Bernoulli trials or Z values, something like that, at that stage you've got to start taking it personally. Okay, there's something deeper work there. What probably means the examiner he hates. There's a 6-year somewhere in the country he hates, and he's trying to get back at this person. You guys just collateral damage. It's like blowing up a whole building to get one person, okay? So, I mean, if this happens, if you don't get Bernoulli trials, okay, or you don't get Z values, there's no inferential statistics, okay? He's deliberately trying to take someone out, and the rest of you are just going along for the ride, okay? But the key thing is everybody's being taken out by the same paper, right? So in this case here, it says a game of chance involves spinning the wheel, shown below, and winning the cash amount in the sector the arrow ends up pointing to. If a player lands on one of the sectors marked with an X, they win nothing. Players pay €30 to play, and you can assume that all 12 sectors on the wheel are equal size. But the only reason it tells you that is it means your chance of landing on any of those sectors is the same. So all of those sectors are equally likely if they're all the same size. So by find there you go expected value. He comes right out. He will always come out right out and use the word expected value. You won't get a question where you're supposed to work out. You do it with expected value. He will use the word expected value. And I would do this with a table, because it's easier to generate marks, right? And for my table there, it's just what happens, what's the outcome, what's the probability, and then multiply them. Because to get an expected value, all you do is you multiply every possible outcome by its probability and add them all together. That's all an expected value is, the long run average. So in other words, if people were to play this game over and over again in large numbers over a long period of time, what will the average score be, the average amount of winnings be? Now, expected value is on the paper all the time. You've probably seen that. It comes up as a short question quite regularly, but that's another one of those bits of probability he can tag in anywhere. Just a random expected value calculation in the middle of a long question that deals with something else. So it's always worth making sure when you see expected value, you know what to do. This table here. So what are the fun things that could happen in the case of this question here? Well, if you look at the wheel, the different sectors you could end up landing on, right? There's a sector marked 200, so you could land on the €200 sector. There's one marked 100, so you could land on that. There's one marked 50, you could land on that. There's one marked 20, you could land on that. Or you could land on the X. So in the wheel there, they're the only different sectors there are. Okay, so you either land on the sector marked 200, 100, 50, 20, or you land on the X. So they're the different things that can happen when you spin the wheel. You know, if the wheel is coloured, you can land on a red, blue, yellow. What are things that can happen when you spin the wheel? That's the first column. Now, what's your outcome there? Well, if you land on the €200, what's your outcome? You could say there, well, that means you win €200. And that wouldn't be wrong. I would always, though, be careful of, see the way we're told you pay €30 to play. So if you land on the €200 segment, you get €200, but you pay €30 to play. So what that means is you're up €170. I think it's more correct to make sure your outcomes include the price of playing. If you don't, that's not wrong. Just subtract the 30 at the end. Okay, but the 30 has to be factored into your expected value somewhere, right? So I would always make sure that the outcome includes any cost of playing. So if you land the 200, you paid €30 to play, you got €200 back, so you're up €170, right? If you land on the 70, or sorry, if you land on the 100, you're up €70, right? If you land the 50, you're up €20. And see, all those people kind of say, I won €20. Did you really? Okay, you won €20. You paid €30 to play. So that, by my calculation, you're down 10. Okay, you haven't made a profit there, so you're down 10. And I landed on the X. I won nothing. It's a little bit worse than that. You lost the €30 cost to play. You're minus 30. So I think the outcomes are more correct if they include the cost of playing. But if you were to put 200, 100, 50, 20, and 0 in the outcomes column, that's correct. You won't mark that wrong, as long as you include the 30 in your final answer. Okay, I'll show you what I mean by that now in a second. So what's the probability? Well, what are the chances of landing on the €200 segment? There's only one of those out of 12, so it's 1 out of 12. Because in the wheel there, the chance of landing on the €200 segment is 1 in 12. There's 12 segments, only one of them is marked 200. Again, same for 100, it's 1 in 12. 50, there's 2 in 12. You don't simplify that to 1/6 because it's not a final answer. Okay, so I can just give that to 2 out of 12. 4 out of 12 then here, and 4 out of 12 here. So it's the chance of landing on each of those kind of segments, right? And all you do now is multiply each pair together and add them up. That's all expected value is. Multiply every outcome by its probability and add them all together. So I got that gives me 85/6. This one here gives me 35/6. That's 10/3. That's minus 10/7. And that's minus 10. And if you add those up all together, you get a nice whole number. You get 10 as your answer. So you multiply each probability by its outcome by its probability and add them all together. That's your expected value. So what that means is, on average here, players are going to win €10. No individual player is going to win €10 because it's not one of your outcomes. It's not possible to win €10 when you spin this wheel. But it's the average. If huge numbers of players were to play this game all day long, on average they're going to win €10. So the people organising this game are going to lose money. Because on average, every time the game is played, they lose money. So remember, because these here, just two things to point out, because the outcomes are from the player's perspective, you're up €170, so is that. Okay? If you were doing this from the organizer's perspective, which is fine, it means every time somebody lands doing it, they're down €170. So it'd be minus 170 and so on. Okay? And then this would be minus 10. So from the organizer's perspective, the average value is minus 10. They on average lose €10 for every time that the game is played, right? And then if you had these numbers here, if you had the outcomes as 200, 150, 20, and 0, what you would have found here was that's 40. Yeah? So what that means is, on average, players win €40, but they all pay €30 to play. So subtract that €30 then, and you get your €10 expected value. So you have to subtract the 30 either at the beginning to give you all the outcomes, or at the end. Make sure you factor that in, otherwise you're not making the case. And to make the game fair, remember what fair means? It means the expected value equals 0. Okay? So the expected value equals 0. So it says, by finding the expected value here, work out how much more the game organizer would need to charge players to make the game fair. €10. Yeah, if they charge everybody €10 more, all of these numbers will go down by the 10, and your expected value would be 0. So just I would mention to him there what fair means. Expected value equals 0. So I have to charge €10 more to make the game fair. Right. Now, Bernoulli trials, part B. Just have a quick blitz through this. So, as I said, it's almost impossible to imagine leaving cert paper 2 where you don't get a Bernoulli trials question. Okay, because it's on the paper all the time. And I think, again, you probably saw the reason I haven't spoken about my, how I felt about paper 1 on Friday is because, I put it kind of out on social media anyway. But my big problem with paper 1 on Friday was it didn't give people who put a lot of practice in a chance to show what they were able to do. If you guys say, look, I put a lot of work and I practiced all the stuff that normally comes up in these papers. I knew how to do all the kind of questions that tend to come up in algebra. I practiced my calculus. I knew how to find areas using integration. I worked on all this stuff here. The question didn't give me a chance to show that. Right? So I would feel the same thing on a paper too. If you don't ask a question of Bernoulli trials or Z values, that kind of stuff, which you know students have practiced, that's out of work they've put in, and you're not giving them a chance to show that. Right? So if you got two papers, maybe one out of paper two, both of which didn't really give you a chance to show the stuff you've worked on, I think that'd be quite a cynical paper. I know it'll still mean that you'll still get the grade you're looking for, the marking adjustments happen. But I mean, I think that there's always that hollow feeling that, yeah, okay, maybe I got my H3, but I'm fairly sure it was just a calculation. The computer somewhere gave me my H3. I don't feel I got the H3 myself. I don't feel I got a chance to show I'm H3 standard. Trust me, once you get into college, you won't care how you got the H3. Okay, if your examiner stood at the top of a staircase, threw the papers down, and everybody in the top step get a H1, I don't care if that's how I got a H1 if it gets me to college. But just when you're coming out of the exam tomorrow morning, there's that deflated feeling that, look, if I do get the grade I'm looking for, I don't feel like I got it the right way. Where I knew how to do this stuff, I showed I was able to do it, and I got the marks accordingly, right? So I don't know that he'd ask two papers where a lot of the stuff you guys would be expecting to see there won't make an appearance. So I'd be very surprised if we don't see Bernoulli trials tomorrow. I'd be very surprised if we don't see Z values and hypotheses, that kind of stuff, okay? That's why the best you can do is make sure you can do those and see where the chips land, right? So this is Bernoulli trials here. Remember, using the Bernoulli trial formula. It says 8 players spin the wheel one after the other. Winning the top prize means landing on the 100 euro sector, right? So it says, find the probability that exactly 3 of them win the top prize. So remember, this is Bernoulli trials because how do you know it's Bernoulli trials? You're repeating the same thing a large number of times. I mean, if there was only 3 people spinning the wheel here, we could probably do a tree diagram or something like that. But when you've got 8 people spinning it, we couldn't do a tree diagram there. Player 1 wins the top prize or doesn't. Then instead of branch player 2, player 3, and so on, the tree would be huge. Not a chance. So this is going to be Bernoulli trials here. So again, I'll set up my formula. So remember, your formula looks like this. So there's the 8 people who are spinning the wheel. And remember, your 2 probabilities. What's the probability of landing on the 200 euro sector? That's 1/12. Right? So remember, we got that already. The chance of landing on the 200 euro sector is 1/12, 1 of 12, which means the probability of not landing on it is 11/12. Remember, those 2 probabilities have to add up to M1. So I'll put down my 2 probabilities like that. Now, don't bother looking the formula up. You don't need to. Let me just show you the quick way of doing this. All right? So we want to find the probability that exactly 3 of them get the top prize. So that's obviously a 3 there. And notice, that's the probability of winning the top prize. So that number there is the number of people that win the top prize. And that's the probability of not winning the top prize. So that number there is the number of people that don't win the top prize. That's what the powers are. So keep them together. So in this case here, for 3 people to win the top prize, it means 3 people win the top prize. That power there is 3. And 5 people don't, because it's 8 people altogether. That's the way to set the formula. Don't go down the whole success and failure route. Right? Because suppose, for example, here he was trying to find the probability that exactly 3 of them land on the X. Because you're counting X's here, that's a success, if you're using the language success. But winning nothing doesn't feel like a success, feels like a failure. So you can very easily get that language jumbled up. So I don't call them success, just the 2 outcomes like that. And I just pop it into your calculator. 8C3, 1/12 to the power of 3, 11 over 12 to the power of 5. And that comes out at about 0.021. It decimalizes it. Okay, so this is 3 decimal places, so it's about 0.021. Okay, so although I'm putting the probabilities as fractions, my calculator decimalizes them and he asks for a decimal place anyway. Okay? Now, more than one of them. Watch out for that calculation. Okay? More than one. So remember, if you spin the wheel, if 8 players play this game, how many of them could win the top prize? Well, nobody could win it, or 1 person, or 2, or 3, or 4, or 5, or 6, or 7, or all 8. There's the number of people who could win the top prize if 8 players play the game. Now, if I was to find this here, the probability that nobody wins the top prize, and then find this is the probability that 1 person does, and the probability that 2 people do, and so on. If I was to find all these numbers here and add them all together, they add up to 1. When every possibility is included in the list there, the probabilities have to add up to 1. Now, I'm trying to find the probability that more than 1 person wins it. So more than 1 person means 2 people, or 3, or 4, or 5, or 6, or 7, or 8. That's what more than 1 means. So I want to know what all those yellow numbers add up to. So I could now just go ahead and start doing the calculations. Find the probability that 2 people win. I already know what 3 is. That's the previous answer. Okay, find the probability that 4 people do, 5, 6, 7, and 8, and add them all together. That's perfectly fine. Full mark answer. You're in business. Would it not be quicker, though, to find these 2 here and subtract from 1? So a question like that just rewards maybe somebody takes a step back and thinks about it before they launch in, because I can just save myself a little bit of time. So I'm going to find the 0 and the 1, and I'm going to work down from there. So you've got this one here, 8 like that, and there's the 1/12th, and there's the 11/12ths. And for no winners, that means nobody won and all 12 people didn't. Just fill in your powers like that. And that comes out at 0.499. And then find out that 1 person wins. So again, set your formula up like that. It's always going to look like that, remember? Those bits don't change. The number at the top there and the 2 probabilities. And for 1 person to win, that means 1 person won and 11 people didn't. So because that's the probability that somebody didn't win, that's the number of people who didn't win. That's the probability that somebody won, that's the probability the number of people that won. And that comes out at 0.363. And then if I've got those 2 numbers there, subtract them from 1 to find what the rest of them add up to. So 1 minus 0.499 minus 0.363 is equal to 0.138. That's your answer. Okay, so that one there, using the formula once for an exactly question, and then this one here where you're asked to find at least or at most, when it's worth just thinking about that for a second. Would it be quicker to find the ones I'm looking for and add them all together, or find the ones I'm not looking for and deduct them from 1? You can just save yourself a little bit of heavy lifting if you do that. Now, this bit here, part 3, every year, pretty much every year we ask this, and every year the same people make the same mistake. Okay, they get this one wrong. And if you're with me when I did this earlier on in the year, just remind you that this mistake here is so common, it gets a shout out in the marking scheme. So anybody who did this, shout out to you, you get 4 out of 10, jogging on. Okay, so it says find the probability the 6th player to spin the wheel is the 2nd one to win the top prize. So you're going to say, okay, so far only 6 people have done this, and we've got 2 winners, so I'll do this. I'll go 6C2. We've got our 1/12th like that. We've got our 11 out of 12 like that, and that means 2 people have won so far, 4 people haven't. I'll put that into my calculator. Wrong. Collect your 4 marks in reception, okay, on your way out, right? So you get your low partial credit there. That's the mistake. Because the problem with that is, remember, that's to find the probability that any 2 of the first 6 people won the top prize, okay? It doesn't guarantee that player number 6 is one of the 2 people to win. And the question makes that clear. The person number 6 won, and they were the 2nd person to do so. So that calculation doesn't guarantee that person number 6 is one of the winners. That's why it's not right. Okay, you've done some maths there, so you get your 4 marks, but you won't get any more than that. So what you want to do for that one, remember, when you're looking for a particular number of success in a particular number of trial, take that last person out of the picture altogether. Person number 6. We know they won. What would have to have happened on the previous 5? So doesn't that mean that 1 of the first 5 won, and then person number 6 won? That's what happened there. So for person number 6 to be the 2nd winner, it means 1 of the first 5 people won, and then so did person number 6. So this bit you do with the formula, right? It's 5 people playing, 1 winner so far. So 1/12 to the power of 1, and 11 over 12 to the power of 4. That's the probability that 1 of the first 5 people won, and just means multiply. What's the probability that person number 6 won? Well, that's just an individual person. It's just a single 1 over 12, probability of winning there. And you just multiply all that out, and you get 0.025. That's your answer. Keep your eyes open for that one. So, if he asks, if it's a normal Leaving Cert paper 2, the chances are he'll throw a question like that on there. Given what happened on Friday, question 7 might be draw a label diagram of the human digestive system. Who knows? Okay, but just assuming that we do actually get a maths paper 2, it's very probable we'll see questions like that. All right. And the last part of that question, this is the one now that he asks quite a bit. Do you remember the first time he asked this? Back in 2017, I think it's maybe just before I fall out of your paper there. It's the question that I almost can't teach. I get choked up teaching the question. You know the one about poor Connor? Poor Connor who's ringing his girlfriend. every day for a week, and the chance of her answering the phone is really low. So she absolutely is not interested. But poor old Connor, like a Labrador, just keeps ringing her day after day. And the question asks, how many times does Connor have to ring the house? So chance of answering it at least once is over 95%. And it's like a month or something like that. Okay, so Connor, as I said before, if you're doing that question, you'll be screaming at the page. Will one of Connor's mates, for Christ's sake, take him out for a pint and say, Connor, you need to move on? She doesn't care. Okay, she's not remotely interested. So this is the version of the question that's come up several times now. Okay, hasn't asked for the last 2 years. Do you remember the Group O blood donation question? He asked it in there, lovely question, that one, same idea. So find the minimum number of players that would need to play the game. So the probability of at least one of them winning the top prize is greater than 0.95. Now, there's that at least again. So you don't have to write this down, but think about this for a second. We don't know how many people are playing this game altogether here. So let's say n players play the game, right? How many winners could we have? Well, nobody could win, or one person, or two, or three, or so, all the way down to n. There's the number of people who could end up winning. So if n people play the game, the number of people who could end up winning is from 0 down to n, right? And we know if we worked out all those properties and add them all together, they add up to 1. So we want to find the probability that at least one person wins. So that's the probability that one person wins, or 2, or 3, or 4, blah, blah, it's all these. So it's all those yellow numbers added together. That's the probability that at least one person wins. One person does, or 2, or 3, all the way down to n, right? So again, would it not be quicker, if we want to find the probability that at least one person wins, to find this here, the probability that nobody wins, and subtract it from 1? That's how you find that. The probability that at least one person wins is 1 minus the probability that no one does. Okay? That's how you do that. So the probability that at least one person wins is always 1 minus the probability that nobody does. Because I want to find the probability that nobody wins. So it's like n, like that. There's the number of people who've gone. And the two probabilities are 1/2 and 11/12. Isn't it? And then the probability that nobody wins, that means 0 there. And we had no winners. And that means all n people don't win. There's your calculation. Same, using the formula again. That idea there. Now, this here is just a 1. Because any number C0 is a 1. Remember that's just making combinations. So if you've got n objects to choose from, how many ways can you choose 0? Just one way, pick none of them. Okay? So that's a 1 there, always. And the power of 0 is also 1. So the first two bits there will always just be 1s. So I just get 11/12 to the power of n. That's the probability of nobody winning. Or sorry, of nobody winning, landing on the top prize. So the probability of at least one person winning is 1 minus that. There we go. That's the probability of at least one person winning. That's the trick with this question here. And remember, we want that to be greater than 0.95. Don't do it as an inequality. Okay, I know you put in bigger than 0.95 because you're going to be using logs here, and inequality signs don't behave themselves when logs are involved. So just treat it as an equal sign, find the value of n, and then take the first whole number above that, right? So put it equal to 0.95. And then just find the first whole, when you get your value for n, and then just always round up. Get the first whole number above. So I'm just going to swap the sides here. Right, so if I move the 0.95 over to the left hand, it becomes negative. So 1 minus 0.95 is 0.05. And then we move this guy over on the left-hand side. And there you go. There's a bog standard exponential equation. Okay, so remember, how do we get rid of exponent like that? We use logs. Okay, so log to the base, this number here, we'll remove it. So on the right-hand side, log to the base 11/12, like that. The log and the power opposite, they will cancel, and just leave the n behind. So I'm going to go with log to the base 11/12 of 0.05. And that comes out as 34.4. So again, always round up. So 35 people. So if 35 people play the game, the chance of at least one of them landing on the top prize is above 0.95. Now, okay, our last probability question is a nice quick one. Okay, and then we finish out, we take a break on this, so we're ahead of schedule, take a decent little break, get a chance to get some water in, go for a stroll if you need to. All right, so question 7 there. This is something I get asked quite a lot. Okay, that you get people kind of saying, will you send me a list of all the formulas that are not in the formula booklet, that I need to know? Okay, this kind of stuff here. That there aren't very many. I mean, the whole point of a formula book is that pretty much everything is in there. But in probability, there are kind of 2 rules and 2 definitions that are not in your formula book that I would know. Okay, so so for probability, I would just know these guys here. Okay, so 2 rules and 2 definitions. So this one here, the union rule. The probability of A union B, that's the probability of either one of these things happening, is the probability of A plus the probability of B minus the probability of the intersection. Because that removes double counting. So remember, in a Venn diagram, right, if that's A and that's B there, remember A intersection B is the overlap there. So if we count everything inside that circle, that's A. Everything inside that circle, that's B. We would have counted the middle bit twice, so we subtract to go. So that's your union probability there. Probability of A union B is probability of A plus probability of B minus the probability of the intersection to remove double counting, right? And the other rule that's on your formula is the conditional probability. It's the probability of A given B is just both of them above the line, the probability of A intersection B above the line, and whichever one is second in the bracket here goes below the line. Now, they're the only 2 rules you need. That's it. Those 2 rules are 2. They're not in the formula, but those are 2 that you expect you to remember. The other 2 things are mathematical definitions, right? So remember, the most important one is the mathematical definition for independent, not the word definition. That independent means that the outcome of one trial has no impact on the outcome of the other, or something along those lines. Okay, the mathematical definition is that if the 2 events are independent, the probability of A times the probability of B is equal to the probability of the intersection. Now, that's an important one. So if you want to show that 2 events are independent, work out those numbers there and see if that statement's true. If it's true, they're independent. If it's not true, they're not. Or if you know that events are independent, you know that's true. You can do a calculation that way. Make sure you've got that one. That independent one is the important one, right? Less useful, less important is the mathematical definition for mutually exclusive, which remember means that they can't both happen at the same time. That's just the probability of the intersection is 0. They can't both happen. The overlap, the bit in the middle is equal to 0. Now that's it. That's all I need for probability. That's my little toolkit for doing this kind of probability. It was on the paper last year, but it's quite common anyway, so it's not like you won't ask it again. So if you got those 2 rules, those 2 definitions, that's all you need, okay, to answer this kind of probability. And because it's our last probability question, we're not going to kind of do any more than that. Okay, we'll take our break then. So look what it says here. It says the A and B are 2 events, such that the probability of A is 0.24, the probability of B is 0.75, and the probability of A union B is 0.81. Find the intersection. So again, once I see this written down here, see it, this guy here, I'll write down my formula from memory, because that's going to, if you write down a formula that's not in the formula booklet, he should give you the low partial for that. He won't give you formula points, not a game show, marks for writing down a formula that's in your formula booklet. So all you did was transcribe it. You're not getting marks for that. Give me a break, all right? So if it's a formula that's not in the book that you've remembered, you will. So the probability of A union B is the probability of A plus the probability of B. Take away the intersection. Okay, there's my partial credit. And I just fill in the numbers I've got. So I know what A union B is. That's 0.81 there. A is 0.24. B is 0.75. And there's the one I'm looking for. Perfect. So now I'm done. Easy peasy. Lemon squeezy. Right? Once I remember my formula, that it's not too hard. Just write down the formula, fill in the numbers, and it's not too hard to do. But I mean, if I didn't have that, I'm in trouble. I'd be struggling to make any progress here. I'd be trying to maybe do a Venn diagram and maybe try to sort it out that way. It's just more work, right? So if I move these 2 over onto the left-hand side here, they both become negative. I'll get minus 0.18 is equal to minus the probability of A intersection B, and then just change the signs. So 0.18 is your answer. Wow. Okay, it's nice and straightforward. So part 2 then, are they mutually exclusive? See what all that's asking there? What he doesn't want here, Lord save us, he doesn't want you guys writing essays, writing paragraphs about what mutually exclusive means. I don't care. So you could spend the next 20 minutes explaining in huge detail what mutually exclusive means, and I will give you 0. I would take marks away from you if I can for making me read all that bullshit, okay, but I can't. The best I can do is give you a 0, but that's what you're getting. He's not asking what mutually exclusive means. He says, are they mutually exclusive? So you've got a mathematical definition. If they were mutually exclusive, the intersection, probably A intersection B, is 0. It's not from the previous part of the question. So if you said the probability of A intersection B is equal to 0.18, it's not equal to 0, therefore they are not mutually exclusive. That's your mathematical definition. That's how you answer that. So he's not looking for you to explain what mutually exclusive means. He just says, are they? And that's what your mathematical definition does for you. So because intersection is not equal to 0, that's all he wants to see. Probability of intersection B is not equal to 0, therefore they're not mutually exclusive. Show that they're independent. Perfect. Do this all day, right? So remember, I'll just write this down first. If they're independent, this is true. Right, there's my definition for independence. So if the numbers I have here satisfy that equation, they're independent. It's much easier than trying to waffle out what independence means. Right? So let's just work out what this is. So probability of A times the probability of B. It's 0.24 multiplied by 0.75, which is 0.18. Perfect. Because that's what probability of A intersection B is. See, that's equal to 0.18. So they are the same. So because probability of A times the probability of B is equal to the probability of A intersection B, therefore they're independent. So that's how you use those two definitions. Or if he told you, for example, that the two events are independent, means that's true. So you see the word independent, write that down. Because it's going to get partial and it's going to be part of your solution. And then finally, the last part of the probability question, then find the probability of B given A. Remember that vertical line means given. So the probability of B given A is just the probability of both of them above the line. And remember, B intersection A and intersection B mean the same thing. So it's the intersection of the two of them above the line. And whichever one is second goes below the line. Okay? So probability of A intersection B is 0.18. Probability of A is 0.24. So if you divide one by the other, you get 0.75. Now, you would have got full marks there if you remember, there's another way of defining independence. That if two events are independent means the probability of B given A is the same as the probability of B on its own. Because whether or not A has happened has no impact on this. And you can see probability B is 0.75. So if you wrote it down that way, that's perfectly fine. But I don't need that definition. If you start trying to add that to your toolkit, that's just more stuff I have bouncing around in my head that could confuse me. So if I had that, I could answer the question that way, but I don't need it. I've got my answer there. It's 0.75. Full marks. Okay, guys, so that's a big chunk of it done there. So we're at 5 to 12 now. So how about say we go maybe a quarter past? Okay, because we've got some trigonometry and geometry to go there. So we give ourselves a little break here. Quarter past, we pick it up from there again. Right. Okay, guys, so just obviously we don't have as much heavy stuff to cover in the second part of the class here. It's kind of the more geometry, trigonometry, shape-based stuff for the second part of the class. So I want to do a little bit of trig first, and then we kind of finish up with the geometries. But just before we do, I just want to talk very briefly proofs, constructions, and that kind of stuff. Just kind of mention that. Certainly, as what I would not be recommending is that if you haven't learned any proofs or constructions, I'm not sure going home and spending the night trying to do that is a good use of your time. I'm sure you would have strategized earlier on whether you're going to do proofs or constructions, and I wouldn't start rethinking that strategy now. Okay, that I think, if you spend the whole night tonight learning off proofs and construction, they don't appear in the paper, that's an evening wasted. Okay, but just to kind of point out that one thing I would maybe look over, that remember that there, on the notes for you here, there is a list of the proofs and constructions for paper 2 there on page 35. Page 35 and 36 of the notes there. So page 35, there's the 11 proofs that are formal for paper 2. Now remember, there's absolutely no guarantee he's going to ask a proof at all. He didn't last year. He didn't ask a proof on either paper, so there's no guarantees at all, okay, that he's going to ask a proof. There were no proofs on paper 1 on Friday. So I guess it's possible, rather than leaving it 2 full years without doing any proofs, he might put one on the paper tomorrow. Okay, that's possible, right? What I would suggest is that if you haven't done any proofs, do you see these 4 proofs here? These short trig proofs, 5, 6, 7, 8 there. I might look over those because they're all only 2 or 3 lines, and they are by far more likely than anything else to be examined. Okay, they're the ones that have been said. The top 4 here have never been examined on the paper. These 4 down here get examined kind of every second year thereabouts. Okay, and I'm going to show you one of those now. Right, they're very quick. So that I would, I think I would have a look at. Remember 2 years ago, we examined theorem 11. So maybe if I'm in the market for the top grade, if I'm in the market for H1 particular, I might have a look at the 2 theorems just in case, the 12 and 13. Okay, that's a possibility. But what I wouldn't be doing now is going and learning out of proofs. If you haven't done any before, I'm not going to spend the evening learning off proofs at this stage because there's no guarantee they'll make an appearance. It could be a complete waste of an evening. Remember, if you do get a question with a proof, you can skip it using your choice. Or if you're not looking for the top grades, you can even take a hit and say, look, I'll do that question. Even though I can't attempt the proof very well, I'll do the question anyway because I can still get a lot of the other marks. I don't need pristine questions if I'm not looking for one of the top grades. Right? But I'll just show you those 4 very quickly. All right? In terms of constructions, okay, remember the list of constructions there on the next page. Again, if you haven't done constructions yet, I'm not sure that's a great use of your time. Okay, given that you may not get one at all, but certainly the ones, if you were doing constructions, the ones I'd make sure I know are those 4, the 4 centers of a triangle. Okay, the one he hasn't examined yet is the incentre. He's asked the other 3. He's done the orthocenter, centroid, and circumcenter a couple of times. So he might throw those on the paper there, all right? And the one about dividing a line segment to equal parts, he hasn't examined that one yet either. So again, I'm not sitting here saying what you need to do now. If you haven't done your constructions, go home and get a piece of paper, get your geometry set out and practice. Okay, because then, he doesn't ask a construction tomorrow. You've wasted your entire evening. I've got to go into witness protection, all right? So I'm not saying go and do that this evening, but just they're the kind of things that if you're trying to pare this back, that's what I'd look at. But certainly, those 4 short trig proofs there, I think I'd probably know those because they're quite easy to do, even without learning them. Okay, all I would remember here is, do you see these guys here? Even remember the order that they're in. So that these 5 here, see the order that they're in. So what you've got there is that number 1 on that of that list there is the cosine A minus B. You don't even remember what it's equal to because you get that on page 14. Okay, you've got cosine A minus B. Then you've got cosine A plus B. You've got cosine 2A. Right? You've got sine A plus B. And you've got tan A plus B. And then actually you can do variation of that as well. You can freestyle once you've got those, all right? So just to show you the basic idea here, that if you're trying to prove any of these 5 here, which are the ones that are on the list, you can use any proof higher than that on the list as your starting point without having to prove that first. So let's say, for example, that you open up the paper tomorrow and he asks you to prove this guy here, cosine A plus B. That's to prove the cosine A plus B formula, right? I know that cosine A minus B is higher than that in the list, right? So I go to page 14 and I find my cosine A, they're on page 14 of the formula booklet. I go to page 14 and I find my formula for cosine A minus B. See it? So cosine A minus B, there it is up at the top of the page. There's cosine A minus B, right? So you grab that one. See it? So you'd be writing down then that cosine A minus B is equal to cosine A cosine B plus sine A sine B, right? So I know that one's, I don't have to prove that one. That's higher on the list. So the examiner knows that's true. So that if I want to prove what cosine A plus B is, do you see all you've got to do? Just take this formula here and replace B with minus B, right? So take this formula here and replace the B on both sides with minus B. So what happens then, you can see on the left-hand side, is you get a cosine of A minus minus B like that. See it? And you get cosine A cosine minus B sine A sine minus B. See it? That's all you do there on that one. And then here, minus minus B, there's your cosine A plus B. And all I got to work out now is what do these two turn into to give me the final answer, right? What sine and minus A, and page 13 to the rescue. Look at page 13 up here. That'll tell you that cosine of minus A is just cosine A, and sine of minus A is minus sine A. So this here just turns into cosine B. So you get cosine A cosine B. And this here turns into minus sine B, so you get minus sine A sine B. Because the minus sine, that becomes minus sine B. I just pull the minus sign out here, and that's your proof. That's how you prove that one. That's one of the required proofs. That's all there is to it. So if you just remember, as I said, those five there, just as they're written there, don't remember what the entire formulas are. You can use any one higher on the list again. So suppose you were asked to prove cosine 2A. Do you see how you can prove cosine 2A, if that's what the question has to do? Can't I grab this one here, because it's higher on the list, and just replace B with A? Then I get cosine A plus A, which is 2A, and then just put A's on the right-hand side and tidy it up, and that's my proof. So those proofs are quite easy to do. If you're asked to prove one that's not on that list, suppose you asked to prove what sine A minus B is. That's on the list. But can't I take this guy here, sine A plus B, and replace B with minus B on the right and left-hand sides and tidy up? So that's really all there is to those proofs. That's what's examined most commonly. So that's something, we're going to have a look at one of those now, but that's what I would make sure I can do. Okay, just that if nothing else. Don't start learning off loads of extra proofs here or worrying about the big ones here. If you just remember that basic idea there, that variations on cosine A minus B and cosine A plus B, sine A minus B, sine A plus B, tan A minus B, tan A plus B, they're all quite quick and easy to do. All right, and they're by far the most commonly examined proofs. Right, so that's what I think in terms of proofs and constructions. So don't go learning loads of proofs and constructions this evening, guys. If you've already made your strategy, your pick for what you're going to learn, just check the ones you've already done. Okay, don't do any ones you haven't done. But if you haven't done any proofs at all, given there were none on paper one at all, it might just be worth having a look at those short ones there, just in case that's part of the trigonometry test, which it might very well be. So at least I've got those in the bag. Okay, for a top grade, I think, you know, that the more proofs and constructions I know, the better. Because if you do get an awkward paper like the one we got on Friday, awkward, we call it awkward for want of a better term, okay, that what you want to make sure is that the questions that I could have prepared for, I do well on. I want to maximize my score on the questions that are familiar, that I know how to do, and then just see how I do on the questions I'm less sure how to make a stab at. Okay, so back at the notes here then, just in terms of doing a little bit of trig. So the first question we have a look at there is question 11. It's on page 26. Right. So question 11 then on page 26. So look at this one here. Prove that cosine 2A is equal to cosine squared A minus sine squared A. Okay, so let's just say I remember these five. Just remember this order here. We've got cosine A minus B. That's the first one you learn. Then you've got cosine A plus B. Then you've got cosine 2A. You've got sine A plus B. And you've got tan A plus B. Okay, in that order, right? So because it's this one here I'm trying to prove, I can use any proof higher than that as my starting point. So I think, you know, I could, if I want to, I could take that one there and replace B with minus A, Yeah, because a minus minus a is a plus a, which is 2a. That'd be fine. Or I could use this one here and replace b with just a. They're both perfectly fine. So I can use any proof higher than this, than the one I'm trying to prove on the list as my starting point. And if I'm trying to prove something that's not on that list of 5, I can use any of those 5 as my starting point. So I'm going to use this one here as my starting point, cosine 2a. Or sorry, cosine a plus b. So cosine a plus b. Don't need to learn what that is. That's on page 14. So you can see cosine a plus b. There it is up at the top. This guy here. Cosine a plus b. Cosine a, cosine b minus sine a, sine b. Okay, so it's cosine A, cosine B, minus sine A, sine B. So I just grabbed that guy from page 14 of my formula booklet. Just tell the examiner where I found that. And then what I'm going to do, replace B with A. See, if I replace the B in the formula with A, I'm going to get cosine A plus A on the left. Okay, and on the right, cosine A minus sine A, sine A. So all I've done there is taken the formula from page 14 and replaced the A's on both B's on both sides with A's. And what have we got on the left-hand side? A plus A is 2A. There's your cosine 2A. And notice here, cosine A by cosine A is cosine squared A. And sine A by sine A, so that's an A there as well. Okay, and sine A by sine A is minus sine squared A. And yay, job done. Piece of piss. So those little trig proofs are not too hard to do. Okay, if you just even remember that sequence of 5 there, okay, the nightmare scenario is he asks you to prove that. Remember, that's the one that takes like a page and a half. So if you're asked to prove that one there, this question is, what do I run out of first, paper or the will to live? Okay, that's a horrible one. So again, if I get asked that one, I take that personally. Right, so really, you're going to give me that paper 1 on Friday, and then paper 2, you're going to ask me that proof? Okay, so I mean, again, as I said, if you do that, I say just take a kind of a broader, more laid back approach there. He's trying to take out somebody else, and you're just getting caught in the crossfire. But so is everybody else. So there's nothing I can do about that. I'll just have to take that on the chin. All right. So cosine A minus B is the really long proof. Again, if you've learned that one, great. If you haven't, do not go home tonight and try and learn cosine A minus B. Absolutely atrocious use of your time. But you can see that proof there is not too bad. Now, prove that sine 3x, and as I said, if he asks you to prove something that's not on that list, okay, like for example, tan A minus B, I can use any of the ones on that list as my starting point. So if I was trying to prove tan A minus B, I don't know, I take that one there and replace B with minus B. And see, and your input minus B on the right-hand side and tidy everything up. That's all there is to it. And all these formulas are on page 14. So for example, look at part B. Prove that sine 3x is equal to 3 cosine squared x sine x minus sine q x. There's a horrible one. Okay, so let me see. Can I just not get 0? Remember, that's the plan here. Just don't lose your place in the pack. Okay, I just want to make sure that everybody else looking for the same grade I'm not doing any worse than they are. We're kind of still holding our position. All right? So in this case here, sine 3x. How about I take this formula here? Because that's on my list. Sine A plus B. Right? So let's go and get the sine A plus B formula. Okay, what's that from page 14? So there's sine A plus B. See it? It's this guy here. Sine A cosine B plus cosine A sine B. Okay? So that's sine A cosine B plus cosine A sine B. Right? That's one of the ones on my list, so I can use that as a starting point. And how about we replace A and B with 2x and x? And let's say that works. It doesn't matter. The order doesn't matter. Yeah? So if I say, look, let's put A equal to 2x and B equal to x. Why? Because 2x plus x will give me the 3x in the bracket on the left-hand side. And just see. That's the idea. That's a tricky one as well. But again, if I've got the idea, look, I can use any of these guys here as my starting point because they are already entered in evidence. The examiner knows you guys know they're true because you learned to prove them. Okay, you mightn't have studied how to prove them, but you learned how to prove them at some point. So we can use those as a starting point. Okay, so let's do that then. So I've got sine 2x plus x is equal to sine 2x cosine x plus cosine 2x sine x. So just replace them on the a's with 2x and the b's with x's. So there's your sine 3x on this side here. And this is just kind of sine 2x cosine x plus cosine 2x sine x. And of course, that's the partial credit. That's a big step in the right. Now, it doesn't quite match what I've got here, but that's a step in the right direction. Do you notice in the case of, in the case this one here, in the right-hand side here, there's no 2x's anywhere. See it? It's cosine squared x sine x, sine cubed x. There's no 2x's. So if I spotted that, I say, look, can I maybe get rid of this guy here and this guy here? So that's how what my thought process might be there. Can I get rid of those? So remember, we're dealing with kind of a worst case scenario here where you get a tricky proof like this. This is how I would build it myself, okay, if I'm trying to put a proof together. So can I maybe swap this? Well, if I go to page 14 of my formula booklet, because obviously what I want to do there is I've no idea what's on page 14. So it's not like you've learned off what's on page 14. So you know you can just go back and find the formula there. Okay, you've heard me say that before, that anybody who knows exactly what's on page 14 will be going to their devs on their own. All right, so page 14 here, if you look at this one down here, okay, cosine 2a and sine 2a. Look, I've got formulas down there for cosine 2a and sine 2a. So if I swap those out and see what happens, see it? So cosine 2a is cosine squared a minus sine squared a. So what I'll do is, look, I'll swap this guy out here for 2 sine x cosine x, because that's what page 14 told me. And I'll swap this guy out here for cosine squared x minus sine squared x, as page 14 told me that as well. Right? So they're both on page 14. And if you multiply those brackets out, you do get this. And that's mission accomplished. Now, so I'm not pretending for a second that's not a very difficult proof. But the idea here is that if you've got some idea, because a lot of people don't know how to start. Because see, for example, if you're asked to prove that one there, that formula itself is actually on page 14. You can say, why do I need to prove anything? It's on page 14. Okay, so it's kind of knowing where you can start. How far back do I have to go to prove this? Okay, so as I said, if you remember that's at a 5 there, to prove any of the ones on that list there, you can use any one higher on the list as your starting point. And to prove something that's not on that list, you can use any of those as your starting point. And at least then I can at least make a start on the question and get stuck in. I wouldn't be anticipating a proof as difficult as that. But then again, I wasn't anticipating a paper like Friday's. Okay, so anticipating, that's as far as anticipating goes. So just again, the thing is here, I don't want to walk away with nothing. Okay, for me, that's a great opportunity for, look, if I'm looking for a H3 or something, a lot of other H3 candidates will probably end up leaving that one blank. So could I even maybe do the top line like this and get that far and get those 4 marks and either hold my position or improve my position in the pack and try to improve my grade? That's my thought process. So don't be freaked out by tricky questions, guys. Just kind of get stuck in and have a go with them. Right, question 10 then. Not too bad, this one. Middle of the road. So solve for x in the following equation. So again, a trig equation. I would be hoping to see a nice trig equation in the paper tomorrow. Why? Because anybody who's been to the past exam will have practiced those inside out, and it's a great chance to start building a score. Okay, so get stuck into it. Remember, as I said to you, in your advice before the paper on Friday, okay, before the class on Thursday evening, when you're doing the paper, start with the questions you're most confident in your ability to do. So identify, look, these ones I can do. Do those first, because you'll do them quickly without having to use up much of your clock, because you won't be stopping to chew your pencil, right? So if you get a trig equation, I can do that. I'll do that one very early on and try and get my score moving, right? So just get everything over onto the right-hand side first. So root 2 times cosine 3x equals -1. Move the 1 across. And then divide by root 2. You get cosine 3x equals -1 over root 2. So that's what a trig equation normally looks like. Cosine, sine, or tan of something equals a number, right? So remember your sequence of steps there. Now, I know many of you have kind of been doing trigonometry with me all year. You know that my aversion to the cast circle. It's an awful learning for very little reward. I mean, that's not what I would do at all. Remember, the 3 steps in doing an equation like this to begin with are, first of all, get your reference angle for low partial credit, and then pick your quadrants and find the size of an angle in each of those 2 quadrants. Okay, so in this case here, if I just finally get the reference angle first, I'll just get 3x is the just inverse cosine of both sides. Just don't worry about the minus sign. You don't have to bring the minus 1 over root 2. If the number is negative, you can ignore the minus sign. The only benefit, the importance of the minus sign is it tells you what quadrant your answers are in. It has no bearing on the size of the angle. Just get the inverse cosine of 1 over root 2, and that's 45 degrees. Remember, we're in degrees here because he wants the answer in degrees. If we're in radians, put into radian mode. Okay, actually, a few of you have run the suggestion past me. He said, what I'm going to do, here's my plan for paper 2. I'm bringing in 2 calculators. One of them set to degrees and one of them set to radians. Because I keep forgetting to switch between them. To which my response was, how do you know you're not going to forget which calculator to use? So if you tend to forget to switch the mode of the one calculator you've got, how do you know you won't forget to switch calculators? And you can kind of see the bits moving. Oh, yeah, I think that's true. All right, so I wouldn't, and you can bring more than one calculator in, but I wouldn't be saying I'll bring one in radian, one in degree mode, because then you've got to worry which calculator am I using. Okay, the only time that's benefit if you don't know how to switch between degrees and radians. Okay, I've got my pink degree calculator and my blue radian one. So is this a pink or blue question? Oh, hang on. It's degrees here. This is a pink calculator job. Okay, so 45 degrees. That's your reference angle. That's low partial credit. Now, pick your quadrants. Don't use the cast circle. I do it this way, remember? I'm sure you've seen these diagrams before. These 3 little diagrams here to pick for sine, cosine, or tan. Okay, so for sine, the top 2 are plus, the bottom 2 are minus. For cosine, the 2 on the left, the 2 on the right are plus, the 2 on the left are minus. And for tan, they just alternate. Plus, minus, plus, minus. That's how you pick your quadrants. You can use the cast circle. Don't start rethinking anything now, but that's what I do instead. Okay? So if you look at that then, those 3. So because what I've got here is I've got a cosine. See the way my equation has cosine value, which is negative. Which quadrants have negative cosine values? That's these 2 here. Second and third quadrants. That's where cosine's negative. That's all I need. Quadrant 2 and quadrant 3. Right? And then how do you find the size of an angle? Remember, in quadrant 1, it's 0 plus the angle. Quadrant 2, it's 180 minus. Quadrant 3, it's 180 plus. And quadrant 4, it's 360 minus. Right? So for quadrant 2, it'll be 180 minus the angle. So it's 180 minus 45, which is 135. And for quadrant 3, it's 180 plus the angle, which is 225. Right? So that's how I solved a trig equation. So just get your reference angle, use this to decide which quadrants your answers are in, and then just make sure you know how to find an angle each quadrant. In the first quadrant, 0 plus your reference angle. Quadrant 2, remember the quadrants are numbered that way. It's 1, 2, 3, 4. You always start in geometry measuring from the positive x-axis, and you go anti-clockwise. Okay, so quadrant 1, it's 180, 0 plus. Quadrant 2, it's 180 minus. Quadrant 3, it's 180 plus. And quadrant 4, it's 360 minus. Now, if there was no number here, they're your answers. Job done. So every trig equation will start with those 3 steps. If there's no number for the x, that'll be your answer. If there is a number for the x, I can deal with that now. Don't deal with the 3 in front of the x until you get this right, because now you've got the high partial, and I can worry about the 3 now, right? So the 2 things you got to remember then, that these are both values for 3x, okay? So that means that 3x is 135 and 225. So divide by 3, and x is 45 and 75, right? So they're both values for x. Now remember as well, the number for the x doesn't just change the values, it also changes the number, because it changes the period of the graph. So remember, how do you get the period of a graph? We're going to do kind of a trig graph question in a second, because I think we might get one of those tomorrow. Okay, we'll talk about that in a second. So with the period, to get the period of a graph, divide a full circle by that number there, whatever the number for the x is. So because we're in degree mode here, it's 360 divided by 3, which is 120. So the period of the graph is 120. So all you're going to do now is take these 2 answers here and keep adding 120 until you go outside that range. Then you know you've got them all. Okay, that's how I deal with the 3x. So divide by 3 and then work out what the period is, just keep adding it. So you can see here, if I just do that then, so x is 45 and 75. So if I add 120 here, I get 165, that's fine. Add 120 here, I get 195, that's fine. Okay, add 120 here, I get 285, that's fine. Add 120 here, I get 315, that's fine. If I added 120, I get 405. No, we're outside the range. There's my 6 answers. Job done. Okay, so that's how I would do a trig equation. And again, you know, you're always expecting a trig equation. And I'd like to think if I got one like that, I'm going to maximize my marks on that. I'll knock that one out of the park. Okay, I'll get the marks I'm looking for there. Now, what I'm going to do then, obviously, I want to do the trig graph question very quickly. And then the last trig question is a diagram based, which will lead us nicely to our last topic, geometries, which will bring us up to the end. So it will mean we've had a look at everything on paper 2, just to kind of put all this stuff back on your radar. And you'd be very unlucky not to find a lot of questions on tomorrow's paper based on stuff we've had a look at here, because we've kind of had a look at all the important stuff in each topic. It's the best you can do rather than trying to second guess what the examiner might or might not ask. Now, the question then back on page 19, the trig graph. Remember, he didn't ask a trig graph last year. You got that weird modulusy one as a short question of paper 2, and he didn't ask one at all on paper 1. Question 10 wasn't a trig graph. Remember, it was periodic, but it wasn't trigonometric. So it's very likely you'll see a trig function somewhere on the paper tomorrow. Not guaranteed, there are no guarantees, but it's as good a thing as any to have a look at, right? And so this trig question, because there's a few things I just want to point out in this one. It says a patient's blood pressure. Certainly, I wouldn't be a fan of giving you guys a blood pressure question, okay, during an exam, particularly after paper 1 you had, okay? But a blood pressure varies sinusoidally with time in a manner that can be approximately modeled by the following function. So P of t is k times cosine 25 pi over 9t plus 108. See the way again? There's a reminder here. You're in radians. So straight away, I don't know, switch your calculator radio mode or switch to your pink calculator. Okay, whatever your strategy is in this case here. Okay, so however you work with radians, make sure you switch straight away so you don't forget. Okay, there's a reason why these are in radians, which I'll remind you of now. Okay, where P of t is the blood pressure in millimeters of mercury, and t seconds after the measurement. So remember, this here is in millimeters of mercury, and this here is in seconds. Okay, so we've got the two measurements like that. Now, what I would normally do here, and certainly if I got one tomorrow, I would try sketching the graph first. Remember, if you sketch the graph first, very often you're answering part of the question without even realizing it, okay? So notice it's a cosine graph here, all right? So what the base shape, it's a cosine graph. And remember, the number in front here is positive. How do I know it's positive? Because we're told k is a natural number. Okay, so it's a positive whole number. So k is a natural number. So this is going to be a cosine graph. Okay, so remember, a cosine graph will look like this. Center line like that. Starts at the top, goes down like this, and back up again. Okay, that's what your cosine graph will look like. Basic shape. Now, the 3 magic numbers. Remember, the constant, the number by itself, the 108, that's always your center line. So center line of the graph here is 108. Right? Second number. The number that's in front of the word sine or cosine, that number there is your amplitude. It's how far above and below the center line of your graph is going to go. So this graph's going to go up by k here, and going to go down by k here. So even at this stage, you could say that that's like 108 plus k. You don't have to write that down. And that's 108 minus k, because I don't know what k is yet. So if k was 10, for example, it means the top is 118 and the bottom is 98. So the number for the word cosine is the amplitude, how far above and below the center on your graph goes. And then finally, this number here, remember, the last number, this one, gives you the period. A full circle divided by that number there gives you the period. Just what we used in the previous question. Remember, how do we find the period of that trig graph? So we knew how often the answers repeat themselves. We divided a full circle by the number in front of the x. So a full circle, remember, is going to be 2 pi here because we're in radians. So 2 pi divided by 25 pi over 9. And then that gave me an answer of 0.72. Okay? So that's the period. So in other words, what happens to this blood pressure, it goes from 108 minus plus k down to 108 minus k and back up again, and repeats that every 0.72 seconds. Now, if you get into the habit of sketching that very often without realizing that you're answering part of the questions, but the key thing there, remember your 4 basic shapes, what a sine, minus sine, cosine minus cosine graph look like, and what those 3 numbers do. The constant number by itself is your center line. The number in front of the word sine or cosine is the amplitude, how far above and below the center line your graph will go. And this number here gives you the period. Okay, a full circle divided by that number will give you the period. So look what it says in part 1. The patient's maximum blood pressure is 135. Write down the value of k. Have I or have I not now made that a doddle? Maximum, you can see, is 135. So 108 plus k that's the maximum, is 135. Absolutely fine. Okay, so if I do that calculation there, so it's going to give me what? It's 81. No, sorry, it's 27. K is 27. So that means you can see if K is 27, then that's 135 up there. That's 27, then this one down here is it's 81, isn't it? 108 take away 27, that's 81. So I now know what the maximum minimum are. So just because the maximum point there was 108 plus K, put that equal to 135, and Robert's your mother's brother, you're in business. Okay, so K is 27 then, right? So now look at part 2. Hence or otherwise find the patient's minimum blood pressure. Well, I just did that. Okay, 81. So the sketch made those first 2 bits a doddle. Very, very straightforward. See the or otherwise there? You can probably see what the or otherwise would look like. So people are going to be spending a little bit of time on part 2. Isn't that one of our buzzwords? Minimum. So you could say derivative equal to 0. Differential put equal to 0. Is that wrong? Absolutely not. Perfectly correct. Full marks. Minimum means, so if you differentiate, put it equal to 0, and solve, you will get the right answer and you will get full marks. Of course you will. Takes it a bit longer. Okay, but that's but trust your gut there, that's perfectly fine. But I did it from my sketch, no problem. Part 3. Find the patient's blood pressure 0.15 seconds. Look at that. That number 0.15 seconds. Because it's in seconds, look at your formula. It's a value for t, isn't it? Because t is what's measured in seconds. Okay, so I'll put t equal to 0.15. I know what to do now. Okay, so the p of 0.15 is equal, remember we now know what k is, so k is 27 times cosine 25 pi over 9, t is by 0.15 plus 108. Okay, and there's no penalty for how you round that. It's around about 115. Okay, if you give us a decimal, that's fine. If there's no guidance in the question about rounding, then there's no penalty, however you choose to round. So it's about 115. That's an easy one, just throw some numbers into a formula and go from there. Now, part 4. If you ask a trig function on paper 2, it's pretty inconceivably wouldn't ask this. The one where you put a number on the left-hand side and solve the equation you end up with. Okay, it'd be almost rude not to ask that if you asked a trig graph question on paper 2, right? So look what it says here. Each cycle of the function represents a single cardiac cycle, a single heartbeat. For how long during each cardiac cycle is the patient's blood pressure less than 90 millimeters? So again, look at the number, 90 millimeters of mercury. So because that's measured in millimeters of mercury, that's clearly a value for P of t. That's going in the left-hand side. So just by looking at the units, I know what to do. And remember, as I said, the marking scheme, the low partial credit showed the examiner, I know what you wanted me to do. I just wasn't able to do it. Okay? High partial is, I know what to do, and I made an attempt to do it. And then full marks is, I know what to do, and I did it. So if you know what to do, but you're not sure how to do it, show the examiner that gets your low partial. And that's better than 0, and that holds your position in the pile. Keeps your position packed, right? So I know, because this here, I know the number's going in the left-hand side. Okay, so that's what 90. So 90 is equal to 27 times cosine 25 pi over 9 t plus 108. Okay. So we just go ahead and solve that. So move the 108 across first. Becomes negative. So you get minus 18 is equal to 27 times cosine 25 pi over 9 t. Right? And then divide by 27, and you get minus 18 over 27. You don't need to simplify that. Simplify to what? Minus 2/3. You don't have to. Okay, it's okay to leave it at that because it's going into your calculator in a second. And you see the way now, that one there, that's a trig equation like the one we did back in question 10. So I can now, if I want to find my reference angle, pick my quadrant and divide down the corner. That's perfectly fine. The only thing is when you meet one like this so if you kind of say, look, I'm going to get my reference angle here by getting the inverse cosine of both sides. Okay, I'm going to go ahead and pick my quadrants. Okay, which 2 quadrants are cosine value is negative. Okay, because I'm working in radians, I'll go with pi minus and pi plus. Okay, instead of 180 degrees, and I'll divide down by 25. That's perfectly fine. Full marks. Absolutely fine. But just when you're dealing with a real world question like this, the numbers can get a bit messy. So I tend not to. I just going to go ahead and find what t is, right? Get the inverse cosine of both sides. Okay, like that. So it's absolutely fine to do to just treat like the question we did a moment ago, and that comes out at it's around about 2.3. So I put that in my calculator around about 2.3, and then divide across by 25 pi over 9 to get the t by itself, and t ends up being 0.264 seconds. Okay, so t is equal to 0.264 seconds. So I mean, there's my high partial. So they're a little bit trickier to solve there because the numbers are messy. So get the t by itself. Now we do need 2 times. So if you use the kind of the method we had a moment ago, where you pick your quadrants, find your reference angles, work out what the 2 angles are, and then divide down by the 25 pi over 9, you get the 2 answers that way. If you want to do it this way, look, notice that the graph we've got here. I just want to use my graph instead. All right, so there's the graph like that. Okay, and remember 90 is down here like that. So you can see there's the 2 times when the blood pressure is exactly 90, because the central line is 108. So 90 is down there. So we just found that first time there. That first time there is 0.264. The question is, what's this second one here? Well, remember, the curve is symmetrical. So if the first time is 0.264 in from the left-hand side, the second will be 0.264 in from the right-hand side, right? So in other words, if this is 0.264 here, we're 0.264 in from the left, then this is 0.264 here. And remember, the left-hand side here is 0.72. It's the period that we found earlier on. So the second time then, the other one will just be 0.724, sorry, 0.72, take away 0.264, that's the second time. Okay, and that's 0.456. So there's the 2 times when the blood pressure is exactly 90. So as a dealer's choice, whichever of those 2 methods you prefer. So once you got to that line there, if you recognize that's just a trig equation like the one we did in question 10. Okay, just find your reference angle by getting the inverse cosine, pick your quadrants, and find any of those 2 quadrants, then divide by 25 pi over 9. That's 100% perfectly fine. Okay, you get those 2 answers that way. Otherwise, you can find one of them and then just use the shape of the graph to find the second, whichever makes most sense to you. Okay, but notice it says for how long during each cardiac cycle was the pressure less than that? See it? So just even in your sketch here, all along here, it's less than that. So in between those 2 times, the blood pressure is below that. So I want to subtract them to find the difference between them. So 0.456, take away 0.264, comes out about 0.19. I'll round that final answer to 2 decimal places. Kind of kept 3 until I got down that far, just a better practice, but 0.19 seconds. Tricky little question, that one. But again, if you just kind of, as I said, just put the number in the left-hand side, show you know what to do, and then get the t by itself, that's going to be your high partial. 8 out of 10, I wouldn't be too worried about the rest. Now, just, I suppose, as a final thing, I'm not going to spend a lot of time on this, but just want to flag with you here, because we already dealt with this kind of on Thursday. It is not impossible that those 2 could make an appearance. So, remember, we talked on Thursday that rate means derivative, average means integral. He could ask you to find the derivative or the integral on paper 2 in this context here. Right, so he could ask that. It's just worth reminding you of that. Okay, it's perfectly possible. And remember, we talked on Thursday about how we do those differentiations, number, function, bracket. Right, so the number in front stays put. Page 25 will tell you what the function turns into if you're differentiating, and then you multiply by the derivative of the bracket. I'll just show you that very quickly now. And if you're integrating, number stays put. Page 26 will tell you what the function turns into, and divide by the derivative of the bracket. Right? So I'm not going to do the whole thing out in a lot of detail because the solutions are done there for you. See the way you've got this one here. So the original function there, p of t, is 27 times cosine 25 pi over 9t plus 108. So if I was differentiating this to find my derivative, if you ask for the rate, number function bracket. So the number is that. There's your function, and there's your bracket. So remember, the number stays put. 27 stays where it is. Function, what happens to cosine? Well, because I'm differentiating, I'll go to page 25. That's where the derivatives are. So page 25. Okay, here we go. So what happens? Cosine, there you go. Cosine becomes minus sine. So because I'm differentiating, cosine becomes minus sine. Okay, so that will become minus sine 25 pi over 9. Okay, so the number stays put. Page 25 tells you that because I'm differentiating cosine to the minus sine, and then bracket, you multiply by the derivative bracket. If you differentiate 25 pi over 9t, the t disappears, you just get 25 pi over 9. Right, that's your derivative. And then I would just use my calculator to multiply those two together, and that's your derivative. That's how you do the differentiation. Number function bracket. Remember, the plus 108, that's a constant, that disappears. By difference of constant vanishes altogether, so the 108 disappears, right? So that's how you find your, and then you can see all you'll be doing then is just subbing in that value to get your final answer. So rate could appear on paper 2 tomorrow. I think there was quite a lot of calculus on paper 1, so I wouldn't be expecting it, but just don't be thrown. If you're kind of saying, hang on, that word rate, I think that means calculus, but it couldn't be calculus. This is paper 2. Yeah, rate means derivative. Rate means calculus, okay? And then just remember, if you're asked to find the average value, remember we talked about this on Thursday evening, the first 0.5 seconds, that means between 0 and 0.5. They're your two values. And again, how do you integrate? Number function bracket. So again, the 27 will stay put. So I'd be trying to integrate the function between 0 and 0.5. Okay, again, I'm not doing the whole thing out in a lot of detail, but just in case. Right, that's what I'm doing there. So the two values are 0 and 0.5. I'm going to integrate between those two. So again, when I'm doing this guy here, number function bracket, so the number stays put. Function, what happens cosine? Well, because I'm integrating now, I'll go to page 26. Because that's what the integrals are. And page 26 tells me that cosine becomes plus sine. Okay, perfect. So we'll get, it becomes sine. So we get sine 25 pi over 9t. That's the number stays put. Page 26 talking about the function turns into, and you now divide by the derivative of the bracket, not multiply. So we'll divide by 25 pi over 9. There's my integral, right? And remember, if you differentiate 108, it disappears. If you integrate 108, you put the letter back. Remember, if you integrate 3, you get 3x. So that would be 108t. And then I just evaluate that between my two boundary values, put the 0.5 in, put the 0 in, and get your answer. Okay, and then remember, because it's an average value, then divide your answer by the difference. Divide your answer by 0.5. The difference between those two. That's how you find. So again, we did all that stuff. I just want to put that back on your radar, just on the off chance. Okay, we'd be kind of remiss not to. So they could appear on paper 2 as a rate and average value, and same way we did them on Thursday. Okay, so that's the trig function. So again, as I said, I think that's very possible. I'm not making any predictions. I think it's very clear we can't. I'm not making any predictions, but that's kind of what I talk about there. So the last part, the last thing we're going to have a look at now is just kind of the shape-based stuff. A quick run through the geometry and coordinate geometries and the shape-based trig, and then that's it. That's all of paper 2. So if nothing else, guys, we've had a look at all the important stuff on paper 1 and paper 2. Or sorry, paper 2. If you feel this stuff here, I'm okay on. I'm not too bad on. That's about as good as you can be going into paper 2 tomorrow. Okay, make sure the stuff that the examiner expects you guys to be able to do and that he tests normally is up to scratch. You'll get a lot of questions like this that you'll probably recognize. Maximize your score on those. And if he goes rogue and asks something outside of that, just give it your best shot. But try and keep that picture in your head. All I'm trying to do tomorrow is not underperform compared to the other people who are looking for the same grade I am. If I can hold my place in the pack, I'll get my target grade. If I can improve it, I'll do better than my target grade. That's the idea, right? So question 9 then, just to springboard us into the shape-based stuff. There's nothing kind of very difficult in this. I just want to kind of give you more the strategy involved here. Okay, I don't know. I don't think we'll see a 3D problem. There's one on last year's paper, the pyramid on last year's paper. So I think it might be a flat diagram. If you're going to get any kind of diagram-based trigonometry, it could be flat. So it says competitors in an ultramarathon event are required to complete the course shown in the diagram below. They start from P and they run 5 kilometers to Q. So they start at P and they run 5 kilometers. Okay, so I'm going to put that in there. That's 5. Start at P and they run 5 kilometers to Q. They then run from Q to R. Okay, no, this is given there. Then another 10 kilometers from R to S. So that's 10 there from R to S. Okay, and then they run from S to T and then from T back to P. And notice these two have been marked with dashes. They're the same length, whatever they are. Okay, the angle QPR is 120. So QPR, that's 120 there. All right. PTS is 65.16. Okay, so PTS, that's 65.16. That one there. PR is 16. That's 16 there. And PS is 14. And PT and PS is in that they're already marked. Now, do you notice something here? Well, because I've read the question. Actually, I can do a little bit more, can't I? That just if you kind of spend a minute or two on the diagram here, do you notice that because these two sides here are marked as being equal, doesn't that mean that triangle there is isosceles? Which means that this angle here and this angle here are the same, aren't they? That angle there and that angle there match. And you see, like, I can work out what they are. Because if I subtract 65.16 from 180 and then halve it, I get this angle here and this angle here. Now, if I don't do that at the beginning, it doesn't matter. But if I spend a second or two doing that before I start, that'll probably speed me up further down the road. Okay, that's what I mean by read the question. Put the information in the diagram. See, is there anything else I now know looking at the diagram before I start reading parts of the question? Right? So I could find those two angles marked in yellow quite easily. Okay, because the triangle's isosceles. So find QR. So where the hell is QR? Well, there it is there. So QR is this side here. And you see, because all the information is filled in on the diagram, I can now see at a glance what the best way to solve it is. Remember, if you're going to be picking between sine rule and cosine rule, to use the sine rule, you must have a pair. An angle and the side opposite that angle. If you don't have a pair, it's a cosine rule. So in this triangle here, I know this side, but not the angle opposite it. I know this side, but not the angle opposite. I know this angle, but not the side. So I know it's a cosine rule. I don't have to spend any time worrying about that because I don't have a pairing. It's a cosine rule. So I'll go and I'll grab the cosine rule from page 16. A squared equals B squared plus C squared minus 2BC cosine A. And just remember, when you're using the cosine rule, the side that goes by itself on the left-hand side is always the one opposite the angle. That's all you got to get right there. So in this case here, opposite the angle is QR. That's what I'm looking for. Okay? So QR squared is equal to the other two sides are just 5 and 16 in any order you like. So 5 squared plus 16 squared minus 2 times 5 times 16 times cosine 120. And that right-hand side is all numbers. So that goes right into Captain Casio there, 361. So I get the square root, then QR is the square root of 361, which is a nice round 19. Now, 1 mark penalty if you leave out the units. Just be careful of that. Again, is a cautionary tale from paper 1. I don't want to be leaving any marks behind me on the easy questions, because God knows marks are hard to come by on the difficult ones. So let's make sure that I don't leave any marks in the battlefield for an easy question. So I get the 19 there. I'll just put that in the diagram here. That's 19. Don't know if it helps, but that's 19. Easy 10 marks off and running. Part 2, the angle PRS. Where the hell is PRS? Where are you, PRS? There you go. This guy here. Okay, PRS. So PRS there. Find that angle. So again, sine rule or cosine rule. Can I use my sine rule? Well, I definitely can't use my sine rule here because I don't know any angles. So if you look at the triangle PRS, there's no angle. So I know that it's not a sine rule. It's got to be a cosine rule. Can't be anything else, right? So because that's how you check. Do I have a pairing, a side angle? I don't. Because I don't know any of the angles in that triangle there, I can't use my sine rule. So cosine rule again. Okay, so A squared equals B squared plus C squared minus 2BC cosine A. And this, for me, hear what's happening in the room right now. This is one of the things that we always object to with filling the answer on a booklet. I hate this in a trigonometry question where the diagram is on one page and you're writing on the next. Because what happens all the time there is you guys flick back and maybe the number is 19.8 and you bring it to this page, you get 18.9. You make these transposition errors because you're trying to carry a value from one page to the next. Okay, so if you're doing that, if you're bringing a number forward, I would normally, what I would normally do is I would normally scribble the number on a piece of paper and bring it with me rather than try to keep it in my head, make sure I'm writing it in properly. Okay, what you can do if you really want to is you could say, look, I'll ask the examiner, put your grubby little paw in the air and ask for an extra piece of paper, and I'll do that question on a piece of paper so I can keep the question in front of me while I'm doing the question. You can do that if you want to. But if you're not going to do that, that's a bit messy. Just make sure you carry values carefully. It's a very, very common thing, a transposition error when you move from one page to the next. Okay? And that turning of pages here, you can see where it'll happen. So remember, the side that goes on the left-hand side is the one that's opposite the angle. That's this 14 over here. Okay? That's opposite the angle we're looking for. Okay? So 14 squared is equal to, the other two sides you can see there are 10 and 16. So it's 10 squared plus 16 squared minus 2 times 10 times 16 times cosine A. Now, when you're rearranging the cosine rule like that, just be careful. I know some of you guys learn off what the cosine rule looks like when it's rearranged. I tend not to do that, because if I remember it incorrectly, I've made up a formula, and I don't get the marks for that. What I would do now, once I've filled in the values, because there's your partial credit. You've identified it's a cosine rule question, and you filled it in correctly. So I've got marks so far. Move these two across. They'll just become negative, right? So I get 14 squared minus 10 squared minus 16 squared. And then divide by this, remembering to bring the minus sign with you. That's all you do to rearrange the cosine rule, right? So bring across the minus 2 times 10 times 16. That's how I would rearrange that. Don't go down the road of working out what 14 squared is, and 10 squared is, and 16 squared, and fill it. You don't need to do that. That's waste of time. Okay, so just pop it in like that. And if I put that entire fraction to my calculator, it comes out as a half. So put that together. So that means A then is the inverse cosine of a half, which is 60 degrees. Okay, perfect. So P or S here, that's 60. Right, not too bad. Part 3, find the total length of the course. Okay, now, just be careful here and ask yourself, in an exam, would you have added in these two dotted lines here? Obviously, that's wrong, because he has actually told you in the question how you do the course. He says you run from P to Q to R to S to T and then back to P. So you don't run from S to P or from R to P. So if you include those, that's wrong. Okay, I just need to add the side. So I've got this side here, I've got this side here, I've got this side here. All I need is this side over here. So it's another way of asking, can you find that side over there? Okay, and notice this time I can use my sine rule, because I've got this angle here. See it? I got this angle and the side opposite it. So I do have a pairing this time. Right? 65.1 and 14. And notice to find the other angle then, remember, we could say that, I think we said those two are 57.42. I didn't actually write those in earlier on. Remember we talked about those at the very beginning. Because the triangle's isosceles, if I subtract that from 180 and divide what's left in 2, they're both 57.42. So if I did that at the beginning, this is now a doddle. Yeah, I've got my angles now. So I just write, remember, you can write your sine rule. You can put sides or angles on top. I put the side on top if it's a side I'm looking for. So if you write the pair you know as a fraction, it's 14 over sine 65.16. That's equal to, take it, doesn't matter which one we're going to find. Let's find ST first. So ST over the sine of 57.42. And just multiply up by this guy to put above the line on the left-hand side. So 14 times sine 57.42 over sine 65.16 is ST. And I got that comes out around about 13, it's very close to 13 kilometers. That's 13. Right? So remember, that means that this side here is 13. And because the sides are equal, so is that. So now I've got all the sides, I can just add them together. So that's just a sine rule calculation, no problem. So just 5 plus 19 plus 10 plus 2 13s. Okay, so you can see, add up all the sides on the outside. So your total then is 5 plus 19 plus 10, and then there's 2 13s on the end. And that's a nice round 60 kilometers. Okay. So that's a nice little question there. And I mean, again, that's one now, if we get one of those tomorrow, I'd hope to maximize my score on that. That's not a difficult question. There's not a lot going on there. I should be able to maximize my score on that one there. Part 4 and 5 then, just to finish off. A drone is used for security purposes to monitor the area inside the course. The region monitored by the drone is in the shape of a circle, C, with center O, where O is the midpoint of PS. So that PT and ST are tangents. Find the radius of C. So we go back here. Okay, so we're told that O is the midpoint of PS, and that's the center of the circle. Okay? And we're told that PT and ST are both tangents. So notice, that's what gives me this shape here. It's lovely because you almost think I planned this just to kind of spring us into the circle next, that idea there. That a tangent is always perpendicular to a radius where it hits a circle. That's why that's a right angle there. Okay, so it's the same thing would apply here. If I drew in this radius here, that would be a right angle. So anywhere a tangent meets a circle, you get a right angle. And isn't that the question done then? Look at your diagram. So we're told O is the midpoint of PS, and PS, remember, is 14. So that means this bit here is 7. That bit there is 7. There's your radius there, or, and we've got this angle up here. So now it's a junior cert trigonometry calculation. It's a right angle triangle. I know one of the angles, and I know what one of the sides is, and an angle. Can I find the value of or? Okay, so you can see that if I just do my calculation there, so that's the opposite, and that's the hypotenuse. So sine 57.42 is equal to opposite over hypotenuse, or over 7. So multiply across by 7. 7 times sine 57.42 is equal to or. And that comes out at about 5.9 kilometers. It says 2 decimal places there. I have actually given it to 1. So I would have lost a mark there. I suck. Okay, so or is 5.9. Right? And you can see what the last part of the question is then without kind of doing the whole thing, because I do want to kind of just make sure we jump onto the geometry, just kind of give the class a little time that's left to the geometry, coordinate geometry and geometry. Okay, but last part of the question there, see it? It says, hence find the percentage of the total area enclosed by the course that's monitored by the drone. So do you see what the pieces involved there are? You got to find the total area of that shape, area of the circle, and express what's. So the circle's not too bad because you've got the radius. So pi times 5.9 squared. Do you see, to get the area of the course, all you got to do now is get the area of these 3 triangles. Yeah? Get the area of the three triangles. Remember, to get the area of a triangle, it's just a half AB sine C. So you have 2 sides and the angle in between them. So for this triangle here, I could use this side here, and the 120, a half AB sine C. For the other triangle, I can use this side here, and the 60, a half AB sine C. And for this one here, I could use that angle there, and this one here, half AB sine C. So all I do is find the area of the 3 triangles there, add them together to get the total area, and express the area of the circle as a percentage of that. Not a bad little question, that one. But that's your trig, right? So working with solving equations, working with the formulas and making proofs, trig graphs, and solving diagrams with your sine and cosine rule. Okay, that's the stuff to make sure you have on your toolkit. Again, no predictions, but just that's kind of as good a toolkit as you'd have going in for trigonometry. So let's finish up then with the, so that's the long question stuff. Remember, circle, line, circle, and geometry, probably one short question apiece. So we've probably had a look at all the stuff that will appear in your long questions tomorrow, if you know, the paper's typical. And God knows that's an assumption its own right now, okay? But certainly, if the paper's typical, we've had a look at the stuff that's probably going to appear predominantly in your long questions. Let's just finish up. Quick look at some coordinate geometry and geometry. Okay. Question 12. Last couple of questions. I think that's why we've got 3 questions to go, guys. Hang in there. 3 short questions and we're done. 3 and done. Okay, so question 12. And that's actually, if you think about it, it's not a bad kind of morning's work if we've kind of had a look at all 6 topics on paper 2 and what the important stuff is in there. You could go home this evening and kind of reinforce those, or maybe have a look at 1 or 2 other bits and pieces to buttress your toolkit. But certainly if you're kind of okay-ish with what we've looked at this morning, you kind of have the basic toolkit for every topic on the paper 2 tomorrow, and that's about as good as you can be going in prepped. Okay? So question 12, it says P is the line, x plus 15y minus 83 equals 0. That's this line here. A is the point minus 7, 6. Okay, so that's minus 7, 6 there. B is the point 8, 5. Okay, that's 8, 5 there. And C is the point minus 4, minus 4. Okay. The points, and we're told that A and B are both on the line P. Okay, perfect. So by construction, find the coordinates of the incentre. Now, as I said to you, that's the only construction he hasn't asked yet. So remember, by construction, so if you're constructing the incentre, remember, all you got to do there to find the incentre is divide the angles in half. Do the angle bisector construction on any two corners, right? So if, for example, you got your compass out, put the point of your compass here and drew an arc like that. Don't change the radius, put the point of your compass here and mark an arc out in the middle. Don't change the radius, put the point of your compass here and mark an arc out in the middle. If you join those two together like that, there's your angle bisector. That puts this angle in half. Now, don't rub out your construction lines. If you do, you'll lose all the marks. Because the examiner will assume you got your protractor out, you measure that angle there, halved it and mark the halfway point with your protractor. That's not a construction, right? Pick your second favorite corner and do the same thing, right? Point your compass there, draw an arc, point your compass here, mark an arc out in the middle, point your compass here, mark an arc out in the middle, and join those two together, right? And wherever those two lines meet, that's your incentre, right? And make sure you leave the construction lines visible. And I think in the case this one here, the incentre is almost exactly minus 2, 2. So you can see, obviously, my freehand drawing sucks, okay? Which is why you don't do it freehand. Okay, if you haven't got a geometry set with you tomorrow, there's a construction question. Don't waste your time trying it, right? You know, if you get a summer job cutting grass, and you turn up at someone's door and say, "Do you want me to cut your lawn?" They say yes, and you realise you've no lawnmower. What are you going to do? Get down your hands and knees and chew it like a donkey? Okay, give up. I can't do the job. I'll have to go and do something else. So they say if you haven't got a geometry set, there's no point trying this. People will do that. They'll draw a rough hand so they can I get the marks? No. If you do that, I'll smug, bless, 0, and we move on. Okay? So if you haven't got a construction set, you won't get the marks there. Hence, construct now the incircle. Remember, the incircle is a circle that fits perfectly inside the triangle, touching each side only once. So all three sides are tangents. So how do you find the radius? What I would do to get the radius there, okay, remember, it's going to be perpendicular to one of the sides. So if you just got your set square, right, and placed it down like that. See it that way? So this side is touching the side of the triangle, the side here. If you mark that point there, that's where I put my pencil. And then just draw the circle that way. And it should just touch all three sides. Okay, that's your incircle like that. So that's just it. Just as a construction, that's what that would look like. But just to find the coordinates of the centroid, that's the quick and easy one. There's a formula for getting the area of a centroid, or for getting the coordinates of a centroid. Remember, it's in your formula booklet on page 52. But the easy way to remember the centroid is just average the x coordinates, average the y coordinates. Okay, the formula is x1 plus x2 plus x3 over 3 and y1 plus y2 plus y3 over 3. But you don't need to memorize the formula. Just average the x coordinates, average the y coordinates, right? So you can see for the 3 points there, it's minus 7, 8, and minus 4 over 3. There's the x coordinates. And the y coordinates, it's 6, 5, and minus 4. Okay. So if I do those calculations there, I think it's minus 1, 7 over 3. That's my centroid. Right. Now, okay, just before we do the circle then, look at this one here. Area of a triangle. The kind of question that I make sure I can do for coordinate geometry of the line in particular is the ones where you're working backwards. Look at part 5 here. If he wants to go slightly tricky on coordinate geometry, this is what it might look like. Part 4 is easy. Get the area of the triangle. Right, so remember, you've got the 3 corner points of the triangle. You got a formula for getting the area here. Just remember that you can only use the area formula if one of the corner points is 0, 0. So if you've got your 3 corner points like that, minus 7, 6, 8, 5, and minus 4, 4. Or sorry, minus 4, minus 4. Move any one of them to 0, 0. If you don't do that, If you just use the formula without moving a point first, he'll give you the low partial and he'll jog on. Easy to mark. You can only use the formula if one of the corner points is 0, 0. So it doesn't matter which one you move to 0, 0. So if I move this one to 0, 0, just what did I do to get it there? So what happened? The x coordinate, what happened? The y coordinate. So you can see the x coordinate went up by 7 because I went from -7 to 0. So that's x plus 7. And the y coordinate went from 6, so that's y minus 6. That's the translation that moved -7, 6 to 0, 0. So just do the same to the other two corner points. Okay, so if I add 7 to both corner points there, both x, I get 15, and I get what, 11? Sorry, 15 and 3. Sorry, that's a -4. 15 and 3. And then if I subtract 6 from the y coordinates, I get -1 and -10. And now put those 2 points into your area formula. Remember the area formula, don't get any marks to write it down. It's on page 18. Half x1, y2 minus x2, y1 with a modulus in there. So multiply those two together there first. So it's a half the modulus of -150. Take away, what is it, 3 by 1, which is 3. So my minus 15 by -10, is that right? 15 by -10. So that's a -1. Sorry, that's a -1 there. Yeah. So it's -3. So you get 147 over 2. Now, that's going forwards. That's not too bad. Look at part 5. D is a point on the line P, such that the area of the triangle ACD is equal to the area of the triangle ABC, when A and D are at the same point. Find the coordinates of D. Now, that's a tricky question. So there's another point somewhere on the same line that gives me the same area, right? So see that you've got this. So this triangle here, there's another point maybe up here somewhere. So if I draw that triangle there, that triangle and this one have the same area. I'm asked to find the coordinates of that point up there. That's a hard part. So again, how am I going to get my foot in the door on that? Well, remember, the key thing here, we're told that the point D is on the line P. He wouldn't tell me that that wasn't essential to my solution. It's on the line P. And we haven't yet used the equation of P. We're told the equation of P is x plus 15y minus 83. Right? So that's the equation of the line. Okay? X plus 15y minus 83. The point we're looking for is on that line. So what I can do here, notice, is I can rearrange that line. Suppose I move these two over onto the right-hand side. I get x equals 83 minus 15y. So for any point on this line, the x coordinate is 83 minus 15y. So what that means is the point we're looking for, because it's on that line, has these coordinates here. 83 minus 15y is the x coordinate, y is the y coordinate. That's the point we're looking for. So any point on the line P has those coordinates, right? And remember, the other two coordinates are the points A and C. So it's -7, 6, and -4, -4. So they're the 3 points that make up this triangle. That's the hard part of this question. That's what people struggle with. Okay, so I know the 2 corner points of the triangle are the points I've got already, of A and C. But because D is on the line P, if I rearrange that, they're the coordinates of D there. And I know the area has to equal the same as the previous one, 147 over 2. Right? So again, if I move one of the points to 0, 0, I'm going to move this one to 0, 0 because keep the same translation. So add 7 and subtract 6. So add 7, I get 3. Subtract 6, I get -10. And this one here, add 7. So if you add 7 there, you get 83 minus 15y plus 7, which is 90 minus 15y. Okay, because I'm just adding 7 to that there. So 83 minus 15y plus 7 is 90 minus 15y. And subtract 6 here, I get y minus 6. And now, do you see then what the question wants you to do now? Put these 2 points into your area formula, put it equal to 147 over 2, and solve. So you end up with a modulus equation you can solve there. Now, that's harder work, right? That's working backwards. So that's not easy. But again, the key thing here is, let's say I didn't spot that. Heaven knows that's a possibility, right? I didn't spot that bit there, how to write the point D in terms of the same letter. right? If I did something like just call that point xy, and then move all 3 points like this, including the xy, and sub them into my formula, put it equal to 0, I won't be able to solve the modulus equation because there's 2 letters in there. But I've shown the examiner all the steps, and there's my partial credit, probably mid or high partial credit. That's how I don't get 0. So if I didn't know I could write that point there as 83 minus 15yy, if I call that point there xy, and said, look, when I move that, I get x plus 7 and y minus 6, and put this point and this point into the area formula, and put it equal to 147 over 2, and just simplify it as far as I can, that's high partial. Okay, the trick was knowing I can write this here in terms of y using the equation of the line. My thing in my head is I haven't used the equation yet, why not? Okay. So that's the coordinate geometry of the line question. I'm not going to do the kind solution out there. You can solve the modulus equation yourself further on. I just want to make sure we get a look at the circle. So question 13, second last question then, the circle. This one here. I would expect, unless things haven't gone according to plan, I'd expect the circle tomorrow to be one of your kind of get out of jail cards. Even if the paper is difficult, the circle is dependable. The line's a fake friend. Sometimes the line is there for you and kind of gets you out of trouble. Sometimes the line turns on you badly. Okay, the circle is pretty much always there. It's like a Labrador. Okay, so when you see the circle, when you open the paper, the circle question will be sitting there wagging its tail. Delighted to see you. All right, God knows what the line question will look like. Okay, but the 3 things for the circle, because the circle is huge, and because only a single short question, it's hard for me to convince myself to spend a lot of time on a question that's going to be a single short question. 3 things I'd make sure I have for the circle. Can I work with touching circles, show the circles touch internally or externally, tangents, and chords? And this question just deals with those 3, and I'll just show you those 3 very quickly. And then that's your coordinate geometry of the line and circle, at least dealt with. Okay? So look at question 13 then. C1 and C2 are circles as follows. And notice there's 2 versions of the equation of a circle given there. The version where the brackets have been multiplied out, and the version where they haven't. And in both cases, make 100% sure you know how to find the center and radius. Okay, it's almost guaranteed that's going to be part of your question. You're going to get the equation of a circle in either form there, and start off by finding the center and radius, right? So for C2, we're asked to find the center and radius. This one's not too bad, remember? All you got to do is change the sign of that number there. So you get 13. Okay? Change the sign of that number there. You get 5. That's your center point. And then square root of that is your radius. Okay? And square root of 90 is 3 root 10. So the version where the brackets have not been multiplied out, that's a doddle. Okay, just change the signs of the numbers in the 2 brackets to get your center point, and take the square root of the number on the right-hand side to get your radius. Now, this one here, the one where the brackets have been multiplied, is a little bit trickier. Use page 19. So if I move that 8 over onto the left-hand side first, so x squared plus y squared minus 2x minus 2y minus 8 equals 0. Then put everything on the same side first. And if you go to page 19, remember, you can see here on page 19 of your formula booklet, where the circle is, you've got that formula for the general equation of a circle. There it is there, see it? So there's the equation we're looking for there. X squared plus y squared plus 2gx plus 2fy plus c equals 0. And the same page tells you how to make the center and radius of that circle. That's all on page 19. So if I grab it from page 19, if I just write the formula underneath, okay, remember, you don't have to do it like this, but if you're not sure, there's x squared plus y squared plus 2gx plus 2fy plus c equals 0. That's from page 19. And by comparing them, find the values of g, f, and c. So you see the way they're, look, comparing them there, 2g is minus 2, so g is minus 1. 2f is minus 2, so f is minus 1. And c is minus 8. So pull out your values for g, f, and c. So write the formula from page 19 underneath or above it, and by comparing them, find g, f, and c. And then page 19 tells you the center is minus g minus f, which is minus minus 1, which is 1, and minus minus 1, which is 1. Center is 1, 1. And the radius is the square root of g squared plus f squared minus c. Just fill the values in. So it's g squared is 1, plus f squared is 1, minus c is minus minus 10, which is minus minus 10, which is plus 8. That's root 10. Now, make sure you can do that. your absolute basics in the circle is I can find the center radius if I'm given the equation of a circle. Now, fingers crossed, we get this tomorrow. He didn't ask this last year, and usually he asks it 1 year and 2. So touching circles is a possibility. He might ask you to show that 2 circles touch internally or externally. He asked it 2 years ago, and there was 2 circles touching internally. So you might be getting a question where 2 circles touch externally. If you do, it's a doddle. It's the very least you could do is throw something simple your way, having given you kind of a rough day at the office on Friday. Okay? So how do you show that 2 circles touch externally? Remember, if 2 circles touch externally, it means they meet at only 1 point like that, and 1 circle is outside the other. Internally means they meet at only 1 point, but 1 circle is inside the other like that. So in both cases, they meet at only 1 point. Okay, so how do you show the 2 circles touch externally? Remember, if I find the distance between the 2 centers using my distance formula, if the 2 circles touch externally, that should be equal to 1 radius plus the other. See it? It should be equal to that radius there plus this radius here. So if 2 circles touch externally, the distance between the 2 centers using your distance formula is equal to 1 radius plus the other. If they touch internally, there's the small radius there, right? There's the big radius there. And the distance between the centers is 1 radius minus it. There's that distance there, right? So if the 2 circles touch internally, the distance between the centers is 1 radius minus the other. Because of all the heavy lifting done now, all I've got to do is find the distance between the 2 center points, which is using my distance formula. So the 2 center points are 1, 1 and 13, 5. Just get the distance between them, square root of x2 minus x1, 13 minus 1 squared, plus y2 minus y1, 5 minus 1 squared. And that's equal to, that comes out as 4 root 10. Okay, that's how far apart the 2 centers are. Distance between them. And look at the 2 radii. The radii are root 10 and 3 root 10. So if you add those, you get 4 root 10, so it's true. Now make sure you write that down. Okay? So write down that the sum of the radii, or the 3 radii added together, is root 10 plus 3 root 10, which is also 4 root 10. Okay? And given that sentence, the distance between the centers is equal to the sum of the radii. Therefore, they touch internally. It's a good rule of thumb. Okay, remember that if he asks you to show something, whatever he asks you to show should be your last line. So show the 2 circles touch externally. Okay, there you go. Therefore, they touch externally. If they touch internally, remember, it means that the distance between the centers will be 1 radius minus the other. But I'd set up the very same way. Now, to find the point of contact, you have a few options there. You could, if you want to do the algebra. And you want to find the point where 2 circles intersect. I mean, that's simultaneous equations. So you could subtract 1 circle from the other and then get a line and solve the line simultaneously. That's a lot of work. I would use, remember, the divisor formula. So if you look at the diagram here, remember, so this point here, which the smaller one, that's 30, isn't it 13, 5? Okay, yeah. So that point there is 13, 5, right? And that radius is 3 root 10. And that's 1, 1 there. And that's just root 10. So I'm looking for the point that divides the line segment in the ratio 3 root 10 to root 10. Okay, so remember, you've got a formula for dividing a line segment there. Remember, the way you use that formula is, don't look it up in the tables, right? If you want to find this point here, let's say that point there is 8, 4, and that point there is minus 1, 0, and you want to find a point that divides the ratio 3 to 2. All you're going to do with that formula is multiply each point by the ratio number at the other end, right? So I'll multiply this point here by that number. I'll multiply this point here by that number and divide my answers by 5. Those two add together. That's how you use the formula. So in the case this one here, I'll multiply this point here by that number, by the root 10. I'll multiply this point here by that number, the 3 root 10, and divide by 4 root 10. Now, of course, you can cancel the root 10s if you like. And say the ratio there is 3 to 1, I'll divide by 4. But if you leave the root 10s in, that's perfectly okay because they'll cancel in your calculator. So watch the x coordinates first of all. So let's say it's this x coordinate 1 multiplied by 3. Okay, that's this x coordinate by that number. and then 13 multiplied by 1 plus 13 multiplied by 1, and that's all over 3 plus 1, which is 4. Okay? Same for the y coordinate, so it's that y coordinate 1 multiplied by 3 plus 5 multiplied by 1, and again divide by 4. And that's 16 over 4, which is 4, and that's 8 over 4, which is 2. So 4, 2 is the point of contact. And I'm fairly sure in a leaving cert paper, if he said show they touch externally and find the point of contact, they'd be asked separate questions. Because wouldn't a lot of you have just found show they touch externally and then forgotten to do the point of contact if they're on the same line? He won't ask 2 questions on the same line because the danger is you'll miss one of them. Now, just have that at the back of your mind potentially for the morning. Okay, he didn't ask it last year, and he may not go 3 years without testing it, and it's a doddle. Okay, that's very, very easy maths. Now, look at this one. Tangents. Okay, we're nearly there, guys. Just hang in there. Just this question to finish, and then one short geometry one. And that's a really good morning's work because we've had a look at everything on both papers. So we're nearly there. We just kind of finished this one out. Tangents now is another thing to keep your eye on. I've mentioned this to you already in kind of workshops and weekly grinds. If you're dealing with tangents of the circle, there's loads of stuff in your textbook, loads of methods. And they'll all work. And the danger is kind of, I'm not sure which one to go with, which one to lean into. Anytime I see the word tangent, I always approach the question the same way. Okay? You know this formula here from your formula booklet. Modulus of ax1 plus by1 plus c over the square root of a squared plus b squared. Remember that guy? That'll tell you the distance from a point to a line. Okay? So if you've got a line like this and a point out here, it'll tell you what that is. The shortest distance of the point to the line, remember, which is always a perpendicular like that. Right? So, if you've got a circle like this, if I've got a line, suppose the line looks like that. Sorry, the line looks like that. If I get the distance from that line to the center of the circle, it's bigger than the radius. Yeah? So the line misses the circle altogether. If I've got a line that looks like this, if I get the distance from the line to the center of the circle, it's less than the radius. That means the line's inside the circle, hits the circle twice. The only way the line will be a tangent is if the line looks like that. Okay? The distance from the line to the center of the circle is exactly equal to the radius. That's how I would solve tangent questions. So if a line is a tangent to a circle, it means if you get the distance from the line to the center of the circle using this formula here, it's exactly equal to the radius. So if you get a tangent question, try that first. Because very often, not only will that be a valid solution, it'll be the quickest way of doing it. So if you want to kind of simplify tangents, think of them in those terms. So how does that apply to this one here? Well, look at this. The line is x plus ky minus 8. It's a tangent circle C1. Find the value of k. So there's your line, x plus ky minus 8 equals 0. C1 is the circle. C1 is the one the center is 1, 1, isn't it? So sorry, C1 is the one with the center 1, 1, yeah, and the radius root 10. Okay. So the center is 1, 1, and the radius is root 10. So in order for this line to be a tangent to the circle, it means the distance from this line here to that point should equal the radius root 10. That's where my solution is going to come from, right? So remember, the formula is ax1 plus by1 plus c over the square root of a squared plus b squared. And a, b, and c come from the line. So that's a there, 1. That's b there, k. That's c there, minus 8. There's a, b, and c. And obviously that's x1, y1 there from the point. So put them into your formula. The modulus of ax1 is 1 times 1, which is 1. Plus by1 is k times 1, which is k. Plus c is plus that minus 8 there, that's minus 8. All over the square root of a squared is 1 squared, right? Which is 1. Plus b squared is k squared. That should equal the radius root 10. And that's the equation you're going to solve. So again, it's a tricky question, but that's the approach I'd be taking there. So simplified tangent. As soon as I see the word tangent, I think of that. The distance from the line that is or is not a tangent to the center of the circle using this formula here equals the radius. That's where my solution comes from. So if I just tie that up a little bit, you can see I get the modulus of k minus 7 over Square root 1 plus k squared equals root 10. And how am I going to solve that now? Well, what I'll do is, because the square roots on both sides, I'll square both sides, right? So if I square this side here, I'll square that side there. And just notice something here when you square both sides. When you square the left-hand side, obviously, you just get 10. Because square and square root will cancel. When you square the bottom over here, the square and square root will cancel. I just get 1 plus k squared, right? What happens when you square the top? Well, remember, that's a modulus equation. If you square the top there, the modulus symbol just becomes irrelevant. Remember we talked about that on Thursday night? If you square a modulus, modulus just means if you get a negative answer, drop the minus sign. But squares can't be negative. So I can just ignore that modulus symbol there and square k minus 7 like any other bracket. So the top line is just k minus 7 squared, which is k squared minus 14k plus 49. And you can see now, if I multiply across by 1 plus k squared, I get a bog standard quadratic I can solve to find my value of k. Okay? So let me just multiply both sides there by the 1 plus k. I'm going to get k squared minus 14k plus 49, right? So that's the left-hand side here, because I'm going to multiply both sides by 1 plus k squared, because they'll cancel. On the right-hand side, I'll get 10 plus 10k squared. Okay. I know that we can solve. So I'll put them over here. So I get 9k squared, minus 14k, minus 39, is it? Yeah, minus 39 equals 0. And again, those numbers are messy. So you might go ahead and use your minus b formula. Does actually factorize. Like that. And that's, that one there's, they're both, that's negative, that's positive there. So that's going to give me k is 13 over 9. And it's going to give me k is minus 3. Two possible values for k. Now, again, be careful. So you see, that's a good example. That's one way of doing this, okay? Anytime I see the word tangent, I'll use that one there. And once I get as far as setting up the equation, getting rid of the square root sign, it should be a dot from that point onwards. Be careful. It said find the value of k. See it? And it tells you where k is an integer. Find the value of k, so you will lose marks if you don't cross out the one that's not a whole number. K equal to minus 3, it says the value of k, there's only 1. So again, isn't that one of those now where you hit your face off the table? Okay, I got that fully right. I forgot to cross out 13 over 9. So I might have only lost a mark, but marks were a pretty precious commodity on Friday, weren't they? They were hard to come by, so I don't be throwing them away for not crossing out something like that. Okay, look at this then, the last part of this question, just to show you a chord. Okay, that's tangents. Chords. Anytime you see the word chord, the question will look like this, right? So when you see the word chord, think of this diagram. Remember what a chord is? A chord is a line that joins 2 points in a circle. So if I've got 2 points like that, there's a chord. Now, every chord question will look like this. Every chord question, when you see the word chord. If you go from the very middle of it has to be the center. If you go from the middle of that chord there to the center of the circle, you get a right angle. That's it. That's what I need to remember for chords. If I go from the very center of the chord to the center of the circle, I get a right angle. So I'll be working with this right angle triangle here. It's going to be a Pythagoras theorem question. See it? So that side there is obviously the radius of the circle. Yeah? This side here is half the length of the chord, because you have to go from the middle to get the right angle. And that side there is the distance from this line to that point using the same formula we talked about a moment ago. So what a chord question will invariably involve, you'll have 2 of those, and you use Pythagoras to find the third. So remember that right angle triangle there. If you go from the middle of the chord to the center of the circle, you get a right angle triangle, and Pythagoras theorem is what the question will look like. Right? So in the case of this question here, all right, you can see here, so we've got the line here. I'm sorry, just a simple sketch there. Okay. So we've got the line L, which is, we now know the k is minus 3, right? So we've got x minus 3y minus 8. That's the line L. That's the other circle. Okay, so the circle has a center point, and the other circle has the center point. What's the center point of the other one? It's 13.5, and radius is 3 root 10. Okay, so that's 13.5 there. And the radius is 3 root 10, like that. See it? So that's what we've got here. So we're asked to find the length of the chord that the line cuts here. So do you see how we're going to do this one? Go from the middle of the chord to the center. That's a right angle. Now, which sides do I know? Well, I know this side here. That's the radius of the circle, which we know already is 3 root 10. So I've got that side, right? Can't I find this side here? See it? Because it's the distance from this line to that point using the formula we just looked at. And if I know those two sides, wouldn't I be able to use Pythagoras' theorem then to find this side here, which is half the chord length, and just double that to get the length of the chord? That's what a chord question will look like. It's that right angle triangle. Go from the middle of the chord to the center, you get a right angle triangle, and just Pythagoras' theorem that. That's all the question would look like. So again, if I just found that distance there, the distance from this line to the center point. So again, there's A, B, C. There's x1, y1. So the modulus of ax1 is 13 times 1, which is 13. B times y1 is minus 3 times 5, which is minus 15. Minus c is minus 8. All over the square root of a squared, which is 1 squared, that's 1. Plus b squared is minus 3 squared, which is 9. And you can pop that into your calculator because it's all numbers. Remember, you can put the modulus symbol into your calculator. It's the button marked ABS, absolute value. Okay, the absolute value, you can use that there. So it'll come out as root 10. So this side here is root 10. So now I've got 2 of the 3 sides of that triangle. I can now use Pythagoras' theorem to find the third side. Okay, so not a difficult, not too bad, but they're the three things to make sure you're clear on when you're working with circles. Okay, those how to work with tangents, how to work with chords, and touching circles. If I've got those 3, I'm in business. If I just call this x here then, so 3 root 10 squared is equal to root 10 squared plus x squared. So 90 equals 10 plus x squared. 80 is x squared. So x is equal to the square root of 80, which comes out, what, 4 root 5? Right? That's the little blue line there. And remember, that's half the chord, because you've got to go from the middle of the chord to get that right angle triangle. So if I double that, the chord length is 8 root 5. So I just want to make sure we kind of flagged those 3 things there: how you work with tangents, how you work with chords, and how you work with touching circles. And last part of the question is very simple as well. Just one final piece of the puzzle to include just one other right angle triangle, and then that's the circle done. It says, let O2 be the center of the circle C2, and we know what that point is. Find the length of the tangents drawn from O2 to the circle C1. See the diagram that's given there? So again, that's another Pythagoras question. See it? Because anywhere that the tangent touches the circle, I get a right angle. So if I put a line in here, see it? If I draw that line there, that's a right angle. See it? And if I go from here to here, do you see the way it's another Pythagoras theorem question? What's this distance here? That distance. See it? Isn't that, sorry, I'll just use a different color. Okay. So that distance there is just the radius of C1, isn't it? We found that already. That's root 10. What's this distance here? Well, I know the 2 center points, don't I? And that distance there is the distance between them, which I found earlier on. I was trying to show they touch externally. Remember that? So we found the distance between the 2 centers. That was 4 root 10. That's root 10 there. So you see now, if I use Pythagoras' theorem again, I can find the chord length, or the tangent length. So again, anytime you're asked to find length of a chord or length of a tangent, they're going to be Pythagoras' theorem questions. Okay, and when you're dealing with tangents, anywhere the tangent touches the circle, you get a right angle, which will create a right angle triangle, which give you Pythagoras. Or in chords, if you go from the middle of the chord to the center of the circle, you get a right angle triangle. Okay, that's your coordinate geometry. Right, guys, final question. There's only 2 bits, and then we're done and dusted. All right, well done for hanging in there. One final piece of the puzzle: geometry. Now, as I said, when you're dealing with geometry, Proofs, constructions, you've made your own judgment call on that. How many, how few you're going to have those you're going to do, you've made your call on that. So what else would I be knowing for geometry? Well, the other things, remember, that you want to get right are showing the triangles are congruent or similar. Now, we asked congruent last year. Remember that in short for that part of question 6, which was easy, show two triangles are congruent. So he might go back this year to ask you to show the two triangles are similar and work with similar triangles. That's the last thing I'm going to do with you. So we just do this one part that deals with similar triangles, and I think that's enough for one morning. And as I said, it's a lot to get through. We did all the stats, all the probability. Okay, we've done the trigonometry, all parts of it, and we've done the line, circle, and now a bit of geometry. That's an awful lot to cover in the morning, guys. Okay, but hopefully we've put a lot of this stuff back on your radar. You'd be very unlucky if a lot of that doesn't make an appearance on the paper in the morning. Okay, putting it back on your radar, right? So we'll just look at the similar triangles very quickly here. I'm just going to do that one part, right? So in the diagram of the circle below, P, Q, R, and S are all elements, which means they're on the circle, see? And PR bisects the angle QRS. Okay? So you're asked to prove something here. Now look at that diagram. I can tell you now, if we got that diagram tomorrow, I can tell you for certain what's going to happen here. Okay, you see the mistake that what people are going to fall into straight away? Now what people are going to say tomorrow is T is the center, because it looks like it's around about the center. There is absolutely no reason that if the center point is necessary for your calculation, he will tell you that. So if he doesn't tell you a point's a center, never assume it is, because if you assume it's a center, everything you do from that point onwards gets you 0. It's a bit of an assumption here. There's no reason to think it's a center. There are always two things I would look out for if I'm dealing with circles. You might remember I told you this if you watched the live stream of the workshop I did down in Cork. Okay, when you're dealing with a circle, there's two things I would watch for. First of all, look for radii, right? So if you've got a circle question going on here, look for radii, because if, for example, if you've got two radii like that, right? Remember, those radii are the same length, which means this triangle here is isosceles. Those two angles will match, and that might be where my solution comes from. So if you've got a triangle there, a circle, watch out for radii. Do we have any radii which is the same length, which might give me an isosceles triangle? In this case, because there's no mention of the circle at center point here, I don't see any radii in there, so I don't think that's going to be helpful. But watch out for that. The other thing to watch out for are angles on the same arc. That's the big one here, angles on the same arc. Remember, if you've got a circle that looks like that, if I take these 2 points here, the piece of the circle in between them, that bit, is an arc, right? That's the arc, I know it's called AB, right? So that's the arc AB there. If I join those 2 points to a point somewhere else in the circle, that angle there is sitting on the arc AB, because the AB are the two end points of that angle. So is this one here, sitting on the arc AB, yeah? And any angles that are sitting on the same arc are always the same size. That's one of your little corollaries, all right? So that angle there and that angle there match. They're the two things to watch out for in circles. Do I have radii, which might give me an isosceles triangle? Do I have angles on the same arc, right? So in this case here, I'm asked to, we're told that PR and QS intersect the point T. Prove the triangles PQR. So PQR is this triangle here. See it? PQR. And PQT, the smaller one here, show that those two triangles are similar. So what does similar mean? It means that three angles in one match the three angles in the other. So what you've got to do there is show that any two angles match and say why. Show that any other two angles match and say why. And then you can just conclude the third angle has to match, don't you? Because if two angles match, the third one would have to match to give you a total of 180 in both triangles. So that's your idea when you're trying to show the two triangles are similar. Can I show that they have angles in common? All right, and remember, I talked to you about the marking scheme of this when we were doing that workshop down in Cork, right? If this is worth 10 marks, if you can identify any pair of matching angles, but you can't say why, you'll get 4, right? If you can identify 2 pairs of matching angles, but you can't explain why either of them are true, you'll get 7. Or if you can pick out 1 pair of matching angles and say why the same, you'll get 7. So again, it's very easy to generate the easy marks at the beginning of this question. So if I'm looking at this here, what I'd be saying, look at this angle here, that angle there. Call it, sorry. Okay, this angle here. Let me just number that angle 1. That angle 1 there. Isn't that part common to both triangles? That's in both triangles. So there's my first line straight away. All right? And you can number the angles, remember. A lot of people ask this, can I number the angles of the diagram and refer to it that way? Yes, you can. The one thing I'm a bit skeptical about is the diagram that gets a bit busy or doesn't scan well, okay? I wouldn't like to trust that. So if you're going to number the angles, what I would tend to do is just resketch just a small version of the triangle down here, and just on that diagram number the angles that you're going to number them. As a rule, if you number the diagram, that's perfectly fine, because usually you can read the diagram perfectly fine, and you'll give you the marks there. But if you're numbering the angles, you need to know what you mean by angle 1. So I would think of just resketch the diagram down here, just number the angles as I go along, rather than naming them P, Q, R. You can do whichever way you want to, okay? But in this case here, if I say, look, that the angle QPT is equal to the angle QPR, or you could just say angle 1 equals angle 1, okay, because of the same angle. Perfect. Right? So that's one pair of matching angles. Can I find another pair of matching angles? Okay, is the question. Now, look at this. Let me just show you this, because don't get too bogged down in the language here. He never gives information I don't need. So do you see this angle up here, angle number 2? That one there. See the angle of number 2 there? Isn't that sitting on this arc down here? See this arc down here? So isn't the angle that I've numbered 2 sitting on that arc? Yeah? So is that angle there. So you see the way 2 and 3 are sitting on the same arc. They both have the endpoints of that arc as their endpoints. So angles 2 and 3 are the same. Can you see that? Look at the second piece of the puzzle then. Aren't angles 3 and 4 the same? Yeah? Because we're told in the question that this line here cuts that angle in half. So if 2 and 3 match, and 4 and 3 match, that means 2 and 4 match. That's your argument there. Do you see it? That's not easy to do, and that's what makes this a slightly trickier question. Okay? So if I just want to kind of write that down now then, okay, that I'll even just number them this time. So angle 2 is equal to angle 3, because they're on the same arc. Right? Angle 4 equals angle 3, because PR bisects it. That was given the question. PR bisects QRS. So if 2 is equal to 3 and 4 is equal to 3, that means angle 2 is equal to angle 4. There's your second pair of angles that match. See it? And that means the remaining angle in both triangles, that's this angle here. Sorry, that's this angle here. Is the remaining angle of the big triangle, and this angle here. Those two angles there, call that angle 4 and that angle 5. They have to match as well, because they're just the remaining angles of both triangles. So if 2 of the angles match, the third one has to match as well. Okay? So then in number 3, that means angle 4 is equal to angle 5. Just the remaining angles, or that, to give you a total of 180, something along those lines like that. Therefore, they're similar. Therefore, PQR and PQT are similar. So if you're trying to prove the two triangles are similar, try and lay it out like that. There should be 4 lines. Here's one pair of angles that match, and here's why. Here's a second pair of angles that match, and here's why. That means the third pair of angles match to give you the total. Therefore, they're similar. Okay? Now, it might take a little bit of working to get one of those pairs of angles to show that they're fine, but fundamentally, they're the 3 lines the examiner's looking for to give you marks for. Okay, so as I said, if you just identified that and nothing else, you get 4 marks. Or if you identified that and that with no justification, you get 7. That line alone will get 7. Just finding a pair and justifying will get you 7. Okay, and you're in business. And then all the question we'll deal with then, remember, is similar. And when we talk this on Thursday, so I won't spend a lot of time on it, similar triangles. Okay, corresponding sides matching. So notice here, in between the red and in this case here, in the smaller triangle, in between the red and green angles is that side there. See, in between angles 1 and angle 5, the red and green angles. And the bigger triangle, in between the red and green angles, is that side there. They're the two. So the 2 blue sides are corresponding. What about in between the in between the black and green angles? So in between the black and green angles here, in the smaller triangle is this side here. And in between the black and green angles, the bigger triangle is that one there. So the 2 green sides are corresponding. And then finally, in between the two remaining angles, it's this side here. Sorry. It's this side here in this triangle, and it's this side here in the other one. Right? So pick out your, and if necessary, sketch the two triangles separately. And remember, if you make the two blue sides into a fraction, the two green sides into a fraction, and the two red sides into a fraction, those fractions are all equal. That's what similar triangles means. We talked about that on Thursday, and that's what you just see the way you just have to prove that there. So if you identify the pairs of fractions and write them as fractions there, you'll see if I take one of those pairs of fractions and cross multiply, I'll get this line here. It's done out for you the solutions anyway. But pick out the corresponding sides and write them as fractions. Now, as I said, guys, just before we kind of break up there, so that's a look at everything there. We kind of touch base with all the important stuff here. Just remember, do not panic if you get another tricky one tomorrow. I doubt it, but it's not impossible. Remember, it's all about holding your place in the pack. If you can do the question and paper every bit as well as other people looking for the same grade as you are, you won't lose your spot. Okay, very best luck, but I hope it goes well for you tomorrow.